Good morning, Seattle, and good afternoon, New York. Guess what day it is? It is
Pi Day.
I'm Jasmine Kiles. I'm a manager of product management here at AWS, and I'm joined with my co-host.
Hi, folks. My name is Adrian San Miguel. I'm Principal Partner Enterprise Architect here at AWS, Pi aficionado, and above all, a fan of puns.
Oh, as a pie aficionado, what's your favorite kind of pie?
I don't know. It's really hard to put my finger on it, but if I had to be irrational that way, I would say it's going to have to be key lime pie.
Key lime.
It is going to be key lime.
Why is that?
Because the key to pie is indeed lime.
Starting early, huh?
Starting early and starting off horribly, to be completely honest with you. But no, folks, thanks so much for joining us. In all seriousness, we're here to talk about a bunch of great launches, a bunch of fantastic things that we've been cooking up. Jasmine, gotta ask, is this your first Pi Day?
It is not.
It is not. Okay, so I'm the only rookie here. What do we have in store for us today?
Well, we have pie.
We do have pie.
Well, today we'll be going through some of our new services that we've just launched here, but the foundation of this is Amazon S3. So Pi Day was created, the broadcast, this is our 5th anniversary of the broadcast. It is also Buckets' birthday. Buckets is our Amazon S3 mascot. And because of that, we are celebrating all things S3, but we're taking you through a little bit of a journey of how we've grown our services here at AWS. So you'll get to see a lot of our AI ML services and what you can do with S3. Using those.
Yeah, it's a really good segue into a lot of things that over on the partner side, especially in speaking with customers, that we're having to help folks realize and really understand that the key to unlocking any gleaning, any learnings about your data estate has to start with quality of data. It has to be on a reliable storage medium. Otherwise, you're kind of just really taking a chance on learning the best that you can off of what you've got. And there's never really any emphasis on, or even just a thought to making sure that it's durable, available, and very intuitive to use.
Yeah, that's what I love. And I love like what we're going to see today. Obviously, we've seen the content. There's probably some fun surprises. But what I love is that we have a live audience with us. So tell us where you're joining from. We're watching the chat all day. I love seeing some happy B-Day Buckets messages in there from Advantage Storage Manager. Let's see what else we have. We have good morning from Seattle. Hi, chat. I saw someone from India. Hello. From Pakistan, London.
I see in Italy, and they're also Buonasera.
SoCal, Brazil. So it looks like we're covering a lot of continents so far. But hey, stick with us, and we'll be answering your questions in the chat if you have something for our speaker. And coming up next, we have. What do we have up?
We have Mr. Andy. Andy is going to be joining us here momentarily. Andy Warfield. He's a VP of Engineering, Distinguished Engineer here at AWS, so stay tuned. He'll be walking us through some really interesting content. Thanks.
Lennar is one of the largest home builders in the United States, operating in over 26 states. In the past, we had a lot of challenges with separate siloed systems. We struggled with data latency and data quality. And by unifying it all together within a Lakehouse in AWS, our quality's gone up, our availability's gone up, and our latency has gone way down. I'm looking forward to the Amazon SageMaker Unified Studio because it'll bring all of the tooling together. It'll allow both our data engineers, our data scientists, and our analysts to operate out of one platform and drive insights much more quickly. One of the things that we anticipate doing with the Amazon SageMaker Lakehouse is to fully leverage the scale that we've built out throughout our S3-based data lake, and to put in production more and more ML models that'll drive insights, predictions, and forecasts that'll drive our business forward. Building on AWS gives us the enterprise scale and support, as well as the ability to manage our cost. It has been a game changer for us as we've jumped into the ecosystem and built out our enterprise data lakehouse. By simplifying our data and making it more available, we're able to drive insights on everything from pricing to materials to our construction processes. This not only will help our customers receive their homes quicker, but it'll also allow us to be more competitive in the market. One of the things that I'm excited about as we move into the future with AWS is leveraging the scale and leveraging the technology that they come to bear with. We spent the last 18 months building a foundation, and now we're going to spend the next 18 months building the future.
Eliminate storage planning headaches by migrating your NAS workloads to Amazon FSx for OpenZFS, featuring the FSx Intelligent-Tiering storage class. FSx Intelligent-Tiering simplifies cloud storage by automatically managing data based on access patterns, providing up to 85% lower costs than the Amazon FSx solid-state drive storage class. and up to 20% lower costs compared to traditional on-premises hard disk drive deployments. FSx Intelligent-Tiering combines the familiarity of NAS with full elasticity and intelligent tiering. It automatically grows and shrinks to fit your dataset as you add and delete files, optimizing costs by moving data across tiers. Benefit from elastic, scalable storage that adapts to varying data access frequencies while ensuring a compelling total cost of ownership for hot and cold datasets. Discover the benefits of FSx Intelligent-Tiering.
Hi everyone, welcome to Pi Day. I'm Andy Warfield. I'm an engineer here at Amazon, and I am happy to be your host to kick off today's Pi Day. We've been doing Pi Day for 5 years now. It started on S3's birthday, obviously 5 years ago, as a way of doing a bit of a deeper dive and telling you about a lot of the things that were happening in S3 in particular, but also across our storage services. Over the 5 years, we've kind of broadened what we do on Pi Day to talk about data all up. And this year, we're talking about a lot of the data stack, ranging all the way from S3 up through our analytics and machine learning tools that a lot of customers use to work with their data. And so today, we're going to cover all of those things, but I get to spend the first 20 or so minutes telling you about some of the high points of the day. One of my favorite parts of Pi Day is the fact that it happens so quickly after reInvent. It's only 3 months after reInvent, but it's a smaller and a little bit more of a casual event, which means that we get an opportunity to get more into the details. The other thing that's really fun about the fact that it happens so quickly after reInvent is that I get to talk about how much has happened in that short period of time. And so, as I'm sure you know, all of our teams race like crazy to launch, prepare talks, and go to reInvent. And at the end of that week in December, everyone, both the attendees and the team at Amazon, are exhausted. We go home, we have some holidays, we relax, and we come back. And in the 98 days, including that downtime, our data and analytics services have launched over 100 new features. And so it's really fun to be here today to tell you about all of the stuff that's already happened in 2025. Now, before I get into a lot of those launches, I'd like to just step back and talk about data and the way that we work with it. Because, as we like to say, every business is ultimately a data business. And one of the remarkable things about the way that customers work with data is the fact that as we get the mechanisms of storing and analyzing data out of the way and build tools that let you just think about questions and be curious with your data and build on top of it, you're able to spot new opportunities that might take your business in entirely new directions and open up new value. One single customer example of this is John Deere. John Deere obviously is a long-standing agriculture and farming equipment company, but they've been incredible in their embrace of data. John Deere instruments over 500,000 vehicles and processes petabytes of agricultural data. In doing so, they're able to spot issues and resolve issues on their equipment ahead of critical points in time during the year when crops are being harvested or planted. They're able to spot patterns environmentally, support sustainability, and provide advice to farmers to make them more effective with their crops. John Deere is a great example of starting with data and finding new opportunities to bring value from it to their customers. And this is exactly how we think about data in the entire stack. A lot of what our teams are focused on is finding those points of friction with asking questions and ultimately take those out of the way so that you can focus on working with curated data sets and the most appropriate tools to use on your data. So as we dive into things, since it's Pi Day, we may as well start with S3. S3 was Amazon's first service to launch publicly. And today, S3 was Amazon's first service to launch publicly. And today, Amazon hosts over 1 million data lakes, 400 trillion objects, and hundreds of millions of requests per second. Innovation is in the DNA of the S3 team. And I really like the visual that we have here across the timeline of S3, notably because when we look at the features that have been launched year over S3's 19 years in operation, what we see is that the team is doing more and more. So despite all of the inside work that you don't see nearly as much of, but that's absolutely critical to scale the service and to keep its operation and its use simple. We're constantly launching new features. And in the past year, there have been some really exciting ones. Now, since it's Pi Day, yesterday evening, we got together all of the S3 engineers across all of the sites where we do work, and we ate a whole bunch of pie. We ordered loads of pies for all the teams, and everybody sat down and had some pie. And so that pie has created the opportunity for my biggest dad joke of the talk. And so what we see on this slide is some pie, a 19th birthday, obviously a bucket. I suspect we'll see a few more of those over the course of today, maybe some that move around a little bit. And it's all on a table. And in the S3 team, we think a lot about tables. In fact, customers have been storing tabular data on S3 for years and years. In 2013, the Apache Parquet file format launched, providing an efficient way to represent tabular data on top of files and objects. Parquet really acted as a bridge between columnar data and the engines at the time, like Hadoop, but later things like Spark and so on that worked with it. And it's grown into like a huge source of use on S3. It's one of our most popular data types. In fact, today, S3 stores exabytes of Apache Parquet data. Customers make over 15 million requests per second to Parquet data. And we serve hundreds of petabytes of Parquet data out to analytics tools and applications every single day. And so as we moved through the last few years, tabular data and the tabular use case was becoming so significant that we decided that tables needed to become a first-class abstraction alongside objects. We saw the growth of OTFs, and in particular Apache Iceberg, which was introduced in 2017. But through the end of that decade and the early 2020s, Iceberg was really starting to see production use in customers. And what we saw with Iceberg was a new first-class table abstraction that allowed things like row-level mutations, support for snapshot-style transactions, time travel, schema evolution. But as we talked to the largest Iceberg customers, we also saw that Iceberg imposed a bunch of work on those customers in terms of table maintenance and taking care of garbage collection, compaction, and ultimately Iceberg created a lot of Parquet files which could cause queries to slow down over time. And so as we talked to these most sophisticated Iceberg customers, we started to hear a strong voice from them asking if we could make those workloads easier, if we could take some of the distracting aspects of hosting Iceberg off of their plates and just give them a primitive that let them work with tables. And it was that voice that led to the S3 tables launch at reInvent last year. Now, the tables launch was really exciting, but what's been really, really rewarding to me has been to see the work that the team has done over those 98 days since we launched S3 tables. We've launched in 8 new regions, making tables available in a total of 11 regions. We simplified and extended APIs by making table creation and schema definition easy at the API level. We've increased the quota to 10,000 S3 tables per table bucket, allowing you to create loads and loads of tables to meet your workload needs. And we've today extended the console to integrate Athena and allow you to easily browse and query the contents of an S3 table. Another place where the team has put a whole bunch of effort over the last 3 months has really been on making sure that we've really finished out the surface of providing Iceberg. And so I'm really excited to announce the general availability of the Iceberg REST Catalog API for S3 tables. When Iceberg was first defined, it was an on-disk format for tables, just like Parquet. It set a convention on how you represent your table data, but not necessarily how you access it. Over the past year in particular, the Iceberg community has really moved to build an API that lets clients have a single library binding over REST to their Iceberg tables and allow access to those tables, even though there might be improvements happening on the data side of working with tables. And so by integrating the IRC, we open up the use of S3 tables to be really simple from a lot of existing Iceberg tools. And as a storage service, from S3's perspective, it's important that Iceberg be incredible as a storage primitive for analytics, but we want it to be a first-class primitive for tables, even for application builders that might want to store primary data in that way. In that sense, tables becomes a bridge between analytics and direct use of structured data. And so I'd like to show you what this actually looks like. Inside Linux shell, inside Python, we pulled up PyIceberg. This is just like a REPL interaction with an S3 table. And what you see here is at reInvent, we launched S3 metadata, which allows you to get the contents of your S3 bucket poured into an S3 table so that you can use SQL to interact with the contents of that bucket. And you see in the interface here, going and running some selects against the bucket and looking for images. What we did next is we used curl to pull down from Amazon Open Data a month of New York taxi cab data, which is one of the data sets that we host in Open Data. And again, we can pull those down, go into Python, load them into an S3 table, browse the schema, and work directly with that data. And the last thing that you see in this is just a little command line call to DuckDB. And I'm going to come back to that one in a second, but first, I'd like to talk to you about DuckDB. Duck is a really powerful library that's used by many applications to bind to structured data. And in launching S3 tables, we really wanted to spend a lot of effort making sure that that developer interface and the connectivity path into data was really, really robust. And since Duck is used from everything from like SQL database backends into certain data types to mobile devices with applications that embed DuckDB to access tabular data, we wanted to make sure that Duck had great support for Iceberg. And so we sat down and sponsored and collaborated with the DuckDB team. And this week, on the 12th, Duck has launched first-class support for the IRC, the Iceberg REST catalog interface, into Iceberg. Now, the Duck team is incredible, and they move really, really fast. And so at the same time, this week, outside of the Iceberg work, they've also launched this really cool new feature called the Duck Local UI. And so let's see what that looks like. I've gone back. The last thing that we did in the last shell was to launch the local UI. And now, using a browser, we can go and interact with that New York taxi cab data directly inside a simple notebook inside Duck. And so this is just a fast way for developers to quickly bind to S3 tables using Duck and work with the contents of it and ask simple queries. And it's just a very, very attractive, developer-friendly approach to working with the data. One thing that we found across these tools with Pi, Iceberg, and Duck is that the table construct as a first-class S3 primitive, having its own endpoint, makes it easy to share structured data between developers and to quickly build tools that work with it. Pendulum is a brand intelligence platform that has the world's most comprehensive coverage across video, audio, and text. And they're an early adopter of S3 tables. And the quote that they have here ends with this point that resonates with me because it sounds a lot like what we're hearing from loads of customers on top of tables. By eliminating the burden of table management, including compaction, snapshots, and file cleanup, our team can focus on what matters the most, which is delivering actionable insights from massive data sets. Now, I'd like to step back from S3 tables for a moment and talk about the rest of our analytics stack, because there's so much more going on above the data layer at Amazon. Now, as you know, across analytics and machine learning, we have a broad suite of purpose-built, best-of-breed tools to work with data. In analytics, this ranges from EMR to Redshift to Athena. On the ML side of things, we have SageMaker and all of the Bedrock suite of tools. And so when we talk to customers and listen to their experience across these tools over the past few years, we hear a lot of love of the individual tools, but also a huge desire to be able to work more collaboratively across them and with their data. And so in talking to these customers, we put an enormous effort into that ability to collaborate and to unify these tools. And so what we launched in preview at reInvent last year was a new version of SageMaker that reimagines and reinvents these tools into a single builder UI. This new version of SageMaker surfaces and allows you to work with your data through all of these tools. Today, SageMaker Unified Studio is launching, and it's structured, as you can see here, as effectively a three-layer stack. At the bottom, we adopt the Lakehouse pattern of building a narrow iceberg-based interface onto data in all sorts of representations. We have a middle layer that provides data and AI governance to allow you to do access control and discovery over all of that data. And at the top, you see a rich collection of our services that builders can choose from to work with their data. And so with today's launch of Amazon SageMaker Unified Studio, we see a new builder-facing interface that integrates not just those tools, but also brings in Bedrock into Unified Studio, as well as Amazon Q Developer into a single UI and developer experience to work with your data. I'd like to dive in for a moment on the Lakehouse end of Studio and talk about how Lakehouse and the integration of Iceberg really lets us bring all of these things together. So not only does Lakehouse allow you to take S3 data lakes, as well as Amazon Redshift, but it also brings in zero ETL integration for operational databases, as well as enterprise data sources like SAP and Salesforce. In addition, we bring in federated querying to hundreds of AWS Glue connections. So this is really an opportunity to bring data from all sorts of sources in under all sorts of engines and analytics tools to work together in a single UI. And through integrating and really investing in Iceberg, we have a unified, open, and secure platform that allows any Iceberg-facing engine or tool to work with that data. And of course, today, with the Iceberg integration for S3 tables, S3 tables also is deeply integrated in the Lakehouse and is a new source of data storage and analysis. Carrier has been an early adopter of the next generation of SageMaker, and we're already seeing them be really excited about the benefits of it. Okay, I'd like to switch now and just give you a preview of what you can expect inside the SageMaker Studio UI. And so the first thing that I'd like to show you is the fact that we have a single sign-on page outside of the AWS console. So this is a builder-facing experience that you can jump into and use right away. As you log in, you get an IDE-style front page that allows you to be very task-focused in how you work with your data in Studio. You can discover AI assets and data sets. You can build with the complete set of analytics tools and a lot of our AI ML products, and you can govern your data. And Studio is really geared around collaboration. In fact, one of the really interesting bits and kind of the coolest part of getting started with Studio is this idea of introducing the project as an abstraction to work with your data. A project is a new abstraction inside Studio, and it's the first thing that you create when you go to do analysis. By creating a project, you get an abstraction that allows you to link users, data assets, and all of the tools that you want to work with. So you get a single space that a set of builders can work in to work on their data and move it forward over time. And so projects really enable collaboration and sharing. This is the view of SageMaker Catalog itself. And in here, you have a complete list of all of the assets that you're working on within a project. And so this is an opportunity for you to work not just across data assets, but also across ML models and all of the other things that you use inside that project. And as you can see, you can search this directly, but the integration with Q means that you can interact with your assets and find things using natural language interactions. Similarly, the query integration with Redshift and Athena inside the Unified Studio IDE allows you to work with these familiar tools in a fully integrated way. And here again, you see Q acting as an opportunity to write queries in natural language and live transform those into SQL, which is actually a really powerful and kind of rewarding thing as a developer, because you can get the broad strokes of your query written out based on just a simple natural language statement, but then you can tune it in the query editor, which is something that I've found really actually speeds up my own work on queries. Finally, we've brought over many of the Bedrock suite of tools into Unified Studio. And by bringing in Bedrock, we gain the ability to work, again, with the same set of data relationships and interactions in a project context and build really advanced ML-based applications, and to bring in Bedrock tools like guardrails to make sure that our applications behave as well as possible. Finally, we folded in the GenAI playground here, and in this view, you can see someone using Nova Reel to do generative video and to actually build a video inside Unified Studio. And so that's a quick whirlwind tour of the Unified Studio experience. I think the best way to learn about Unified Studio is to get your hands dirty and play with it yourself. And the same is true across all of the announcements that you'll see today. So I really hope that you enjoy the rest of the discussions today, that you stick around for Jeff Barr's summary at the end of the day, and most of all, that you go and experiment with a lot of the new things that we've pulled together for this year's Pi Day. Thank you very much.
Storage Browser for Amazon S3 is an open source component you can add to your web applications to provide your end users with an intuitive visual interface to access data stored in S3. With Storage Browser for S3, authorized end users can easily browse, download, upload, copy, and delete data in S3 directly from your applications. You can control access to your data based on your end users' identities using AWS security and identity services or your own managed services. And you can also customize the interface to match your existing application's design and branding. Storage Browser for S3 automatically enhances uploads for high-throughput data transfer, optimizes performance for faster load times, and calculates checksums of the data your users upload, accepting objects after confirming that data integrity was maintained in transit over the public internet. Storage Browser for S3 makes it easier for your web developers to bring your data closer to your users and empowers your customers, partners, and employees by providing a secure and seamless experience for working with data in S3. Use Storage Browser for S3 to increase productivity for your users and to remove undifferentiated heavy lifting from your developers so they can focus on the core features of your applications. Storage Browser for S3 is available in the AWS Amplified JavaScript and React client libraries. Get started today.
Data Cloud is a platform which allows businesses to unify all their customer data so that they can have a trustful, comprehensive view of all their customers in a single experience. As a part of Salesforce Data Cloud, there were a couple of challenges that we saw that we could see the Storage Browser for S3 address for us, primarily around the lines of data management and navigation, to remove data silos and enable an easier access for file management. The solution that we will be developing on top of Storage Browser for Amazon S3 will help our customers more seamlessly connect with their external sources, specifically their S3 tenants. We will be able to provide our customers a single source of truth for all their unstructured data and files within the Salesforce platform, along with a provisioning data access for them, and also help our customers browse, upload, download, copy, and delete their files within the cloud platform. Best of all of this will be made possible in a simple and intuitive interface. Building on AWS ensures both our customers and developers alike are using services that scale with ease and are reliable in nature. And it also makes sure that our developers are no longer focusing on managing and developing IT infrastructure and can actually focusing on creating true customer value. Creating unified and easy-to-use experiences are critical to our team at Data Cloud, and we're always exploring new ways to provide the best experience for our customers. And we see the Storage Browser for S3 as one of these tools that we can leverage and benefit from to deliver the experiences that our customers desire.
And welcome back, folks. Thank you so much for sticking with us and hanging out. My name is Adrian San Miguel. I'm a Principal Partner Enterprise Architect here at AWS and joined yet again by my lovely co-host, Jasmine. Say hey, Jasmine.
Hey, Jasmine.
All right, I asked for that, to be completely honest. I learned a lot in Andy's conversation. There's a lot of really good data points in there, but, as he mentioned DuckDB, the more I hear about it, the more I play with it, the more I realize it really is all that it is quacked up to be. Completely honest with you.
Okay.
Okay, really? That's it?
All right.
Touching on the pendulum use story, I'm really glad we were able to swing that one. And most importantly, talking about how important the database is as a part of your overall architecture. The talk was so good, I'm really holding out hope for a sequel. But enough of that. We're here to talk about something very interesting, something kind of near and dear to my heart. Growing up in the data center as a storage admin, I understand we are joined by a special guest today.
Hi.
Hi.
Would you mind taking a second to introduce yourself and letting us know what your favorite type of pie is?
I'm Ruhi Sood. I'm a product manager on the Amazon S3 team. And I'm going to be talking about S3 metadata today. So S3 metadata is an easy way for customers to get rich metadata about their objects in a queryable manner in iceberg tables that Andy just talked about, in S3 tables. And it's a game changer right now for customers who are trying to parse through their vast data lakes, like you just mentioned, Adrian.
Yeah. So that's actually a great segue. Chat, we've got a question for you. Got a bit of a poll. How many total requests do customers execute daily on S3 data lakes? I promise don't know the answer to this, but odds are you probably do, or at least have a good range. So let us know. And towards the end, we'll circle back to it, see if we can't get that answer. But Ruhi, really curious as to what led the direction to going out and building this in this specific way. What were you hearing from customers?
What we've seen from customers over the past few years is that data lakes are sprawling. And oftentimes these data lakes can contain trillions of objects. And it's challenging to find the right data sets that customers can use for analytics or to train their machine learning models or just to understand, the right storage patterns. It's becoming harder and harder. And this is where we identified that metadata was at the heart of customers' data discovery. And we came up with S3 metadata, which is an easy way for customers to quickly find the right data sets that they can use to train their machine learning models, to just understand the cost, their storage, and also an easy way for you to see your custom metadata that you add to your S3 objects.
Yeah. So that's interesting, Rudy. What kinds of metadata can I generate using this feature?
Oh, I'm glad you asked. So today you can get information about the object. You can get the bucket, the key, the storage class, the size. You also get custom metadata, which includes tags and user-defined metadata. I'll take a minute to explain tags and user-defined metadata. So tags is a way for customers to add key value pair style metadata to S3 objects. It's mutable, which means that you can change it even after you've uploaded the object. User-defined metadata, on the other hand, is it's also a key value pair style metadata that you can add to the objects at the time of object upload. So it's not mutable. But both of them are great ways if you want to get custom metadata. You're trying to tag an object and say this is related to business X from geography Y. It's super easy for you to do that with these custom metadata options today.
Yeah, I love hearing that. That's super interesting. But our audience is looking for a little bit of metadata on you. So, Ruhi, Adrian asked you a question and you didn't quite get to it. AM Grobe says, I hope Adrian and Jasmine will follow up on the favorite pie. That is an important question.
Okay, I was going to give a very, very universal answer, but I skipped it. My favorite pie is apple pie.
Oh, that's a classic.
And yeah, so that's my favorite pie. And
awesome.
Now, we're talking about different things that hold things together. Let us, kind of pivot to a question that I had as you're speaking, harkening back to my days as a storage admin and even helping architect customer solutions. Having to deal with wanting to tag all the things and be ultra precise gets very tricky because the more you do, the higher this cost, and very likely the bigger the sprawl and more systems, more data to touch. Do you have any guidance or thoughts about this?
Well, again, a very timely question. You can use tags to do that, but I hear you on the cost. We are always listening to our customers, and we just recently dropped the prices on S3 object tags just yesterday by 35% across all regions. So now all the more reason for you to use tags, store your custom metadata, and use S3 metadata to explore your storage landscape.
Awesome. I would love to see what this looks like in practice. Any chance that we can pivot to a demo?
Totally. Let's do it.
Yeah.
Okay. All right. So here I have a bunch of S3 buckets. I'm going to play with this one for a moment. I have some objects prefixed in various ways. The S3 metadata is actually very easy to set up. We're doing it on the console, so it's a little visual, and you can see how easy it is. Okay. All you have to do is set up a metadata configuration. And really what you're setting up, like I said, your metadata goes to S3 tables, which are iceberg tables. You can query them with Athena or some open source engines. So all that you're doing here is providing a destination table bucket. So you go and find a destination table bucket. In this case, I already have one. I'm going to select it. And really, just choose whatever name you want. I'm going to put apple pie here.
Let's do that.
And you go and create your metadata configuration. So while it's building, I have one built out here, just for the purposes of demo. Once it's built out, this is what it looks like. You're going to get a table yarn. You're going to get your table bucket name. And from here, it's playtime. All you got to do is go to Athena, which is the simplest way for us to query here right now. And I'm going to start with just showing you what the table looks like. Here's the table schema. You can actually just preview the table.
Wait a minute. You were able to click from inside the metadata to maintain that context and continue on to start doing queries without having to go reload everything again.
Yes, you are. And my bucket right now, like I was saying, it has a bunch of objects. They're getting deleted, they're getting changed, and you will see very shortly how easy it is for me to see what's happening within my bucket. So right here, we try to explore the schema. You were asking me about what type of metadata do we have today. We've got, like I said, bucket, keys. You can tell what objects are deleted. These are the changes that are happening in my bucket. In this case, these are delete markers because it's a versioned bucket. You can see the storage class. And most interestingly, this is the custom metadata that we have been talking about. So you can see the tags, the user-defined metadata. And what we have right now is also provides you with information about the requester, in this case, the account ID or the source IP that's making the request.
Oh, so no more denying, hey, I didn't make that change, or it wasn't me that dropped the database, or, whoops, sorry, I nuked the bucket.
Did you do that, Adrian?
Yes. That's a story for another day.
I'm going to use the tags today. That's the first query that we're going to run. So let's say your use case is you're trying to run analytics, and you want to avoid everything that has PII. You usually tag your objects. Previously, the way customers would have gotten to this is like they would run get object tagging on their entire storage landscape and then try to parse through this data. Setting up data in this manner is extremely time consuming. But now what you can do right here, I'm going to run a small query, just limited to 10 results for now. What we're going to see here is a list of objects that have PII. And you can just list down objects with PII true or false in this case, and just quickly build your data sets. That's the power of S3 metadata, the ability for you to curate your data sets for ML analytics, storage analysis in a matter of seconds. There's one more interesting use case that I want to bring up. Today you can use Bedrock's async API to actually produce videos that you can store in S3 metadata. Really? And yes, and Bedrock annotates those videos with Amazon Bedrock as the source, and also tells what models are being used to produce that data. And it's a very easy way for customers today to identify what data is is synthetic, what data is raw, original, and we've actually added that to S3 metadata. So if you're using Amazon Bedrock to generate content in S3 tables, in S3 metadata, we can quickly identify which of your objects were generated by Amazon Bedrock. And what we should see here is what I was referring to, which is you can see that this was generated by the Nova Real model, and the content source is Amazon Bedrock.
Nice.
Those are the most popular use cases that we have today.
That is fantastic. Chat, let us know what other type of questions you may have here for us as we are live. I just wanted to make sure that we do touch on that. We had a comment in the chat asking if we were live. Yes, we're absolutely live. This is live. We didn't have a demo dance, which is always the easiest way to tell
whether know that we're live.
Because the demo god must be satiated. It's either the drop of blood or the dance. But for reasons, we're not allowed to do the blood thing anymore.
And that was for KitKat PS. We see you. We're live. Don't, this is not a recording. Hey, how else will we do this? But let us know what questions you have here for Ruhi. We love seeing this S3 metadata in practice. Ruhi, what has been, the feedback from the customers as you've been talking about this? We know that you had a blog post around reInvent time. Like, what's been interesting to hear from customers?
We've had a lot of excitement from customers on this, especially customers who are building these large-scale data lakes have been excited about the ability to get this custom metadata queried in an easy queryable in an easy manner. We're also seeing customers bring their own custom metadata into S3 tables. We actually have a blog on this where you can bring your own custom metadata into S3 tables and join it against these metadata tables to get even more insights than what you can today. And there's also been a lot of buzz around other types, and we're getting a lot of feedback on what other fields, other metadata types customers want to see, and we continue to work on that feedback.
Awesome. All right, we have a question from chat. Peter Jew asked, is there a way to define this metadata via code rather than UI?
Oh, totally. I should have said that. I'm just doing it on the console just to be visual, but you can totally use our APIs, SDKs, or CLI, whatever is your preferred format to maintain your metadata tables and to create them to begin with.
So it sounds like just about any slice or path that you take to go and do this, we're going to be able to find a way to meet you where you are, right?
Yes, totally.
Well, that's awesome. Selfishly, I do a lot of work with partners and customers in this space. I can absolutely see how the ability to bring your own metadata and join with what the service is already offering and exposing is going to be huge, because something that I have been very, very stringent with, and almost to the point of being naggy with some of my partners, is you have to be as precise and crisp as you can with your data labeling strategy, as well as how you access it. That way it doesn't cost you as much to go get it. That way anybody that's looking for it can use either natural language or a very easy to write query, so that it doesn't require tons of complex SQL or usually what the mathematician's favorite language is, Python, to go and figure out exactly what they need to get, how to get it. And the thing we don't talk about in all of that research and churn is how expensive the time of these individuals are, and how that can translate directly into lower amount of dollars to go and do the thing. And something we'd like to focus on a lot is ROI per engagement. So the further we shrink that down, the better for the business. Is that about accurate?
Yeah, that is about accurate. And I think the ability right now for customers to like we were discussing, to bring in custom metadata actually adds to what you're saying here. There is a lot of business value that customers can generate by not having to orchestrate and maintain all of these complex metadata pipelines and spending hours and resources, which could be better put to use on meeting the business goals. All you have to do is just identify the general purpose buckets that you want to tune for your that you want to dig into for metadata or for your business purposes, and turn on S3 metadata, and you can use SQL, like you said, that everyone's favorite way to query metadata.
Yeah. So speaking of using SQL, you've mentioned Amazon Athena, but can this be used with QuickSight, and if so, how?
Yes, yes, totally. You can use it with Amazon Athena. You can use it with Amazon QuickSight. It's very easy to set up with QuickSight. We have a detailed blog post out there which walks us through the steps on how you can set it up with QuickSight. You can also use open source engines to interact directly with these tables. So there are a number of ways out there today that you can use to query this data.
Awesome. We've got a question for the chat from Shmandrew. I butchered that, but I'm sorry. Can I put all of my data into S3 user-defined metadata and use it as an endless database if I wanted to? It's a little controversial. It's spicy. I like it and appreciate it, but curious on your take on that, Ruby.
It depends on what is there are limitations on the size of metadata in user-defined metadata, but as long as you keep within those size limits, you can. If you're actually trying to expand and go beyond, you can use tags. You can do 10 tags per object, so that's another scalable way for you to append more metadata and put everything that you would want into metadata tables.
Awesome. Another question for the chat from Malin Arkin. What is the effective level at which tags can be applied in S3 tables? Can it go down to the table level, or is there something more granular?
So tags today are object level tags, the ones that we're talking about. This is object level metadata. So every single time you add an object to your bucket or you're updating the tags, these are object level tags. There are bucket level tags, but that's different because we're talking about object level metadata here for customers who want insights within their buckets.
Yeah. So in short, tags are not currently supported on S3 tables.
Object tags are supported.
Object tags, but not bucket tags.
Not bucket tags.
Okay, great. Thank you for that delineation, Mark. Ruhi, is there anything else that you'd love to leave for the audience, kind of like as a nugget of wisdom, where they can get started, where they can start kicking the tires, or any generalized guidance you think that would be beneficial for the audience to hear from you?
I highly recommend visiting our product pages, our feature page, to get started. As I mentioned, there is a detailed blog post out there which walks you step by step on how you can set this up. We've also talked about how you can bring your custom metadata in a separate blog post and join it with the S3 metadata tables. Please share your feedback with us. We're constantly working to make this richer and ease your metadata workflow management. Share your feedback with us, and we're always working on customer feedback.
Yeah. Awesome, Ruhi. Thank you. I love going through this. I love when people bring us demos. It is just my favorite thing. But audience, back to you. We had a poll question in the beginning for those of you watching on Twitch, and we asked, how many total requests do customers execute daily on S3 Data Lake? So let's see if we can get the answer to that poll there. And while we are pulling that up, we also have a survey. And so our first 100 people who take the survey, let us know how we're doing, what it is that you want to see. You'll get $25 in AWS credits. I
mean, why not? Why not respond to the survey? Remember, folks, this is a show for you and effectively by you. You tell us what you want to see more of, and we're happy to oblige and get you the type of content that you're looking for. So by all means, take a couple minutes, fill out that survey. We would love to hear from you. But for now, hang tight, stick with us. We'll be back after a quick break, and we look forward to bringing you yet another fantastic piece of content. Thank you so much.
Organizations today manage vast data lakes with millions or even trillions of objects in Amazon S3. Data fuels analytics, machine learning, and AI. It's the essence of modern business. But as data grows, finding the right data becomes a challenge. Customers either don't know what data they have or spend months to years building complex metadata systems that are hard to maintain and keep current. Introducing Amazon S3 Metadata to accelerate data discovery with near real-time rich object metadata stored in fully managed S3 tables. S3 Metadata is designed to automatically refresh the metadata tables to reflect the latest changes as objects are added to and removed from your bucket. With S3 metadata, you can locate and utilize the right data, allowing teams to focus on putting your data to work instead of organizing it. Built on open source technology, S3 metadata is designed to be compatible with a wide range of AWS and third-party engines and applications. With no new software to learn, you can just use your existing tools. Transform data discovery with Amazon S3 metadata so you can understand all the data you have and quickly find it for use in business analytics, content retrieval, AI ML model training, and more. Unlock the full potential of your data. Get started with Amazon S3 metadata today.
Toyota is one of the largest and best automotive providers. Our culture goes back many, many years. But we have over 1,800 dealerships, over 63,000 employees in North America, and have 12 main manufacturing plants, with the 13th being the battery plant coming right up. It's disparate in terms of, you have data lakes, we have other platforms that the data may sit in, we have databases, we have third-party data stores. So how do you create that interconnectedness and that cohesion so that you do not have to spend time just bringing all of your data into one place, but you can actually grab the data from multiple places and then get to that insight and get to those models very quickly? Amazon SageMaker Unified Studio has the promise and the ability to do that. I think this is such an opportunity where we can leverage the catalog, we can leverage the MLOps pipelines, and we can leverage all that suite and the capabilities to launch models rather quickly and be able to share models, right, across the data science community. SageMaker Lakehouse has a lot of promise in terms of making sure that we can pull together data from multiple data stores to be able to now pull data from all of these disparate sources and create a unified way in which we can access this data and then deliver value. Our goal as an organization, and if we want to be competitive, right, in the future, we have to make sure that we change the way in which we're serving up data. It's extremely exciting to see all the development that AWS is doing in many different areas so that we can leverage these capabilities in a much quicker manner. And then again, our focus is really on providing value to the customer so that we're not fighting about where's the data, who owns the data, is it safe and secure, but rather we're spending the time on insight creation.
Hi, and welcome back to AWS Pi Day. I'm Jasmine Kiles, joined here with my co-host, Adrian. How's it going?
It's going, Jasmine.
Yeah.
Hey, folks. My name is Adrian San Miguel. I'm a principal partner enterprise architect here at AWS, Pun and Pi aficionado, and understanding we've still got a lot of stuff in the oven baking for you. But enough about that and this. Jasmine, curious, what is your favorite pie?
It's chicken pot pie.
Ooh, I'm going for savory. I dig it. I dig it.
Savory. It's on the shirt as well. You know?
Is that, oh my, multi-level pun. I love it. I love it.
So you think you're killing the pun game, but I woke up, and was like, oh, I'm going to be punny today.
Oh, and that you are.
Yeah, but hey, enough about us.
Mm-hmm.
We're getting through the Pi Day stuff, but what I'm really excited about now is we're going to talk about storage for AI ML. So we're joined here with some guests. Who are you? Welcome to the show. What's your favorite type of pie?
I'm Venkata Sisla. I'm a senior specialist solutions architect here at AWS. My favorite pie, can we call it a pizza?
Oh, pizza is a pie.
Pizza qualifies as a pie. Then, it is pizza then.
Is the sauce above or below the cheese, though? It matters.
Oh, okay. Above.
Okay. There we go.
All right.
Hey, I'm John Mallory. I'm a go-to-market storage specialist here at AWS, and I'm old school. My favorite is apple pie, but with cheddar in the crust.
Oh, cheddar in the crust.
Yes.
Okay, we got to keep a tally. You're the second person to say apple. It's a classic, but storage. That's what we're here to talk about today, right? So tell us what it is that you've been building for customers.
So we've been helping customers solve their storage problems. So especially, it's exciting times with Gen AI. There's a lot of model builders out there who are building their own custom models, and storage becomes a topic of contention. So we want to educate them and bring them the best practices and, make them more, cost-effective choices and help them along the way around the MO journey.
No, that's an interesting purview and way to look at it. We tend to think about, hey, let's just go build the app, but nobody really thinks about the storage medium or the pattern or how to build it for resilience optimization, etc. It's a great question for a poll. So, folks, what is the top repeatable success storage pattern that customers such as yourselves are starting to use to reduce distributed training time and cost? Because there is no real smoking gun, silver bullet, whatever, slice of life, so to speak, to really solve for everybody across the board. So would you say it's a fair statement that it's going to vary on what your business holds as critical and important versus, anything else that maybe market is doing?
Yeah, I guess probably John.
Okay, yeah, no, I mean, it is very important. I mean, because the reality is, switching to AI/ML, that it's all about data. It doesn't happen without data, and you've got to store that data in the right foundation to make it actionable. So storage is a key critical part of AI/ML.
Now, I guess that's the million-dollar question that I keep hearing from both customers and partners is, what are those type of considerations for customers who are just now getting started? Let's ignore for a minute, and we mean that lovingly. The folks that are a little more advanced in their journey, and we see folks from all phases of the tech adoption curve that are starting to get going. What are the type of things they need to consider when they're building the first Gen AI app?
The first thing they need to consider is to take a deep breath, step back and figure out what they want to do, and then figure out the data they're going to need to do that rather than just jump in. And really the best way to do that is to determine your data strategy and then build a data lake, because a well-formed data lake is going to be the foundation no matter where you go in your journey. So you want to aggregate the data from all the sources that you need, then start to catalog and govern it. Curate it, meaning, set up your data prep pipeline so that you can prepare the data to use. And then ultimately, from there, you're going to extend. And as you progress in your Gen AI journey, you can really, start to use a variety of tools and grow seamlessly as your experience and your use cases grow.
Yeah. And speaking of experienced machine learning customers, how could they use AWS storage and benefit from this?
Yeah, no, and that's where storage really starts to matter, because as you get more experienced, you're probably going to get more advanced in how you're going to customize Gen AI/ML. Like a trend we're seeing, for example, is people will start out with, maybe just doing RAG or kind of prompt engineering, but ultimately they're going to start fine-tuning, pre-training, or even building their own models. And their storage is really going to matter because you're going to need performance, you're going to need scalability, and more data. So for the more advanced ones of you, you need to start to think about high-performance, scalable storage. And I think we have a good demo that's going to take you through that.
Yeah. Are we ready for a demo?
Yeah, absolutely.
Let's jump into it.
Let's see it. What are we talking about today on the demo?
So I'll be showing you how to train a large language model like Llama 8B model using your own data, leveraging AWS SageMaker Hyperpod and Amazon FSx Intelligent-Tiering.
Okay.
So yeah, let's get cracking.
Let's do it.
So in the interest of time, I've actually pre-deployed a few resources that are effective for training, right? So I'm going to walk you through what are the resources that I've already deployed, and then we'll eventually get on to the next steps. So I've got SageMaker Hyperpod stack, which has deployed a bunch of networking networking prerequisites and a file system, FSx Intelligent-Tiering file system. I've got Hyperpod observability stack, which gives us the Grafana workspace, so we can monitor how the training process is coming along with errors or if there's any failures or anything. And then we've got SageMaker Studio, where we will essentially interact with the actual model, the training, and the training process through it. So let's touch a little bit on the FSx Intelligent-Tiering file system. So I've seen a lot of customers, especially large-scale model builders, leverage FSx for Lustre file system. So it's a HPC, so it's a high-performant file system, which gives you ultra-low latency and a very high throughput for your large-scale machine learning needs. So what I've got it deployed here is a persistent 2-type file system. I've provisioned about 1.2 TB, which is more than sufficient for what we need for the demo here today. And we're pulling almost 300 megabytes per second of throughput, so which will also be more than sufficient for the performance of the training exercise here. Lastly, I've enabled data compression, which is going to save me on costs as well as give me a better throughput performance, right? So again, so I've got some monitoring and performance metrics, shown in the service. So this will be really handy for me in terms of monitoring how the training's coming along and how this actual storage system's performing throughout the course of the actual training itself. Cool. So the next step is to log into Amazon SageMaker AI. So we've got the studio here. So if you log into the studio, then you see an interface like this where essentially there's a bunch of options. So the Hyperpod clusters, as you can see, I've already pre-deployed here. The cluster has 4 instance nodes. So it's built with 2 Trainium instances, which are going to be the quite core and doing all the heavy lifting for the training process that we have today. And then we've got 1 login node and 1 controller node, which is going to do all this orchestration from a training perspective. So let's get on with the, so I'm going to run a few CLI commands because we'll effectively SSH into the actual instance that we've deployed as part of the cluster and then go through some steps. Just a quick reminder though, I forgot to mention earlier, so you have a GitHub link repository thrown into the chat. So it's a repository built by our frameworks team. So it has a ton of great examples that you can learn on how you can train on how you can train the large language models and a ton of great examples. So this particular demo also has a referential example from the same repository, so you can probably do it at your own time.
Yeah. Venkata, while you're doing this, is there any way you can make the text a little bit bigger? And then we have a question from the chat. Peter Ju asks, how do we ensure that our client's data is secure on AWS? This is one of the primary concerns we hear while offering RAG and CAG-based AI solutions.
Yeah, absolutely. And I think as part of the actual deployment stack itself, and the repository also shows you a few examples that how we sort of build guardrails around security. So there's encrypting with your own keys, making sure there's permission boundaries from service to service, so that there is always those basic guardrails that go around with the training process. So again, tons of great detail in the repository to sort of explore.
Oh, awesome. Fantastic.
Cool. So hopefully now the screen is visible. The text is clear.
Yep. A little bit better. That's awesome. Thanks.
Cool. So what I'm doing now is essentially I'm setting up like a session manager where I can SSH into the cluster. So again, these details are available in the repository. So as you can see, it's letting us into the Hyperpod cluster there. It's giving us the cluster ID and the login group. So what you're seeing here is it's logged us into the worker group. So what I want to do is I want to log into the controller node instead so that we can do all the training stuff. Cool. So we're now...
And also, thank you. The Linux admin in me really appreciates not caching that key. But I digress. Go on.
We want to show all the best practices, don't we? So.
Yes.
So firstly, I want to take you through a little bit about the model that I've downloaded from Hugging Face, so the Llama 8 billion parameter model and the data set. So then we'll get on with the training process afterwards. So let's go in. Model. So as you can see, I've the model's about 15 GB in size. You can see the tensor files that I've downloaded from Hugging Face, and we've also got the tokenizer files, which are quite critical for the gluing the training process, right? So the next thing we're going to see is I've downloaded a custom dataset. It's a wiki corpus, like a publicly available dataset that I'm utilizing for training. So in your case, you might probably bring in your own dataset from S3. So I've also seen examples where customers, utilize their existing data that's sitting in their data lake. Right now that we're talking about data lakes, you can associate an S3 bucket with FSx for Lustre file system as a data repository, bring all your data in for your training, and then train these models with your own datasets. So let's look at the data that I've downloaded. So it's in the example datasets folder. As you can see, one quick call out though, this particular data set's already been pre-processed and it's effectively tokenized, which means the training process can get along more quicker. So if you bring in your own data, so just bear in mind you'll have to probably do a bit of pre-processing with your own data there. Cool. So the next step is to launch the training X command. So give me one moment. Right. So I'm going to activate the Python environment, which has all the dependency packages pre-installed. So that'll probably be another step that you will find in the GitHub repository in detail. So as you can see, I'm kicking off like a slurm command, a slurm job, which effectively kickstarts the training. So as you can see, I've submitted job number 2. And it's warming up. So while it's warming up, a couple of things I want to mention is the model's already been pre-compiled. So effectively what the compilation step does is it sort of prepares the actual model more effectively to run on the custom AI accelerator. So we are leveraging Neuron Distributed Framework. So since this is running on the Trainium chips, the compilation step is quite crucial to make sure we're utilizing the hardware to the fullest extent and there isn't any idling from a compute standpoint. So since I've already compiled it, the compilation step roughly takes about 25 minutes. So since I've already done it beforehand, the training step's going to skip and then jump straight into the actual, the training process, of course. I'll show you a few interesting things from a monitoring perspective. So cool. So let's log into one of the worker nodes and see the activity from a compute standpoint.
Yeah, that'd be great.
Cool. So as you can see, these are the neuron processors as part of the compute. So they're warming up now. So probably in a few minutes, we should effectively see them fully up and running, all the 15 vCPUs there.
This is harkening back to my my Unix nerd brain back in the day. It reminds me of a Solaris UI and HPOX UI. This is, I'm right at home here.
We have a question in the chat here. Is there a cost estimator?
Yes, we do. So you can definitely leverage AWS pricing calculator and put in the services that are part of the stack that we've deployed, which will give you a kind of an estimate on how much does it cost for you to run.
Okay.
Awesome. Looks like we got a comment in the chat also from KitKat PS. Being hyped to use this for financial modeling.
Oh.
Any thoughts on that as a use case?
Yeah, absolutely. Why not? I think these models are generally pre-trained on general knowledge, I guess, and the fact that you can bring in your own custom data sets and train the models on is, you're up for as many use cases as you want to explore.
Awesome. Thank you for touching on that.
Cool. So while this is warming up, looks like the clusters are still warming up and then they're preloading the data. Oh shit, okay, I think they just came back up. So let me go back in again. As you can see, the full greens, going up 100%. So we're leveraging all the cores from a training perspective. So this is exactly what you want to see. So my training has got about 10,000 steps. So this probably goes around for the next 4 to 5 hours. So in the interest of demo, I'll show you a few more monitoring aspects that you can look out for, just so that you can understand how the training's coming along. So I'm SSHing back into the controller node there.
Yeah, this is okay. Yeah, there we go.
Yep. So now, as you can see, the slurm.2 output, the slurm2 output, it has the detailed output logs of the whole training process.
Okay.
But let us log into the a log where we've already concluded the training so that we can see how the training process has been in the previous instances. So,
and you mentioned that this can sometimes be a multi-hour type of process procedure.
Yes.
That we're condensing for the in the interest of time.
Yes, absolutely.
Okay, awesome.
Sorry, 1 second. Sure. So as you can see, this is one of the sample logs that I'm showing you from the previous case. So it's picked up all the key parameters that's there. Like I said, we're doing 10,000 steps for training, and as you can see, the model paths pointed to the Lustre file system, and the model is also on the file system as well as the data set that we've downloaded and prepped. So these are the things that you can sort of look for from a prerequisite standpoint, and essentially, these are all the continuous logging. So we've enabled quite a very detailed logging to understand how the training process is coming along. But yeah, so since I think you can only learn and explore once you can sort of dive in yourself. So feel free to access the repository, check out all the examples, and and hit us up if you have any questions.
Yeah, I love that you already have this up and ready to go. You have the repository, so folks can go ahead and go. John, what's your recommendation for folks getting started here?
Yeah, no, my recommendation is no matter where you are in your journey, really start to think about building that data foundation, because it's going to take you throughout your entire journey. I mean, you can start out with something as quick and easy as queue with your data in S3, start to adopt Bedrock if you want to take a, wide range of models, customize it with your own data. But ultimately, if you get super sophisticated, you want to dive in like Venkata just showed us, you can really start to train and build your own models.
Yeah. Awesome. So we had a poll at the beginning here. So let's go back and see the results here. If we can pull that up, drum roll, please. If not, I'll start dropping fun facts. All right. So we said, what is the top repeatable success storage pattern customers are using to reduce distributed training time and costs? And everybody went with FX for Lustre, backed by S3.
It gives you the flexibility of rapid fire, easy to access, low latency storage, as well as the durability and reliability of S3. So it's hard to find any fault with that.
Yeah.
Gentlemen, thank you so much for swinging by and spending some time with us today here on Pi Day. Stay tuned, folks. We got some more great content coming for you, and looking forward to getting to it with you and spending some more time. Thanks so much.
Great.
Thank you all.
Rivian is electric adventure vehicle manufacturer. We want to use AWS to enhance our products so that they help our customers be more safe, power more adventures, give them back more time to do things that they really want. We store hundreds of petabytes of data that is collected from our test fleet as well as customer fleet of vehicles. It is used for simulation as well as training. We use Mount Point for Amazon S3 to gain 4 times better performance than our previous solution. We were able to get 4 times faster downloads and up to 2x faster upload speeds for larger file sizes. Mount Point for Amazon S3 is extremely cost effective because it is free to use. It also allows developers to naturally use file-based operations to interact with Amazon S3. Engineers in autonomy can use Mount Point for Amazon S3 to directly access S3 without having to make any changes to their code, which is developed locally using file-based operations. So they can translate this code directly into cloud system like Amazon EC2, or they can use batch with containers or even EKS.
All of our foundation models are trained on AWS. Amazon S3 is a very important component when training Gen AI. We ingest petabytes of multimodality data, so images, videos, music, everything stored on S3, and then streamline into supercomputers on top of SageMaker, and then eventually we're producing a foundation model. Working with AWS allowed Bria to scale from 1 foundation model to today up to 50 foundation model trained on top of supercomputers and using petabytes of data. At Bria, we utilize iceberg tables for our data catalog, meaning that we're taking petabytes of data and we formalize them into tables in order for a research team to be able to curate it real time and query the database to create subset for training dataset. We started with low compute, low amount of data, and the models were very light and small. And today the models are huge, and we're using supercomputers to train these huge models. I think working at Bria puts me in the frontier of a very exciting times of a generative AI era. I think it's a very exciting times and a good place to be at.
Hello and welcome back to AWS Pi Day. I'm Jasmine Kiles, Manager of Product Management here at AWS, and I'm joined here with my co-host and very good friend, Adrian.
Hello, Jasmine. Thank you for that lovely send-off. And surely you're embellishing. I'm not exactly lovely, nor am I particularly good at a lot of things.
Okay, we'll see. You're good at a lot of things, Adrian. Don't ever underestimate yourself. But you know what? I have a fun fact.
Okay.
Did you know that in addition to buckets, someone else had a birthday on March 14th?
I was not aware. Who is that somebody?
Einstein.
Wow. When you think about it, it really is all relative. But again, my name is Adrian San Miguel. I'm a principal partner enterprise architect here at AWS and a pun extraordinaire. But we're not here to talk about puns, even though we're going to slip them in anyway. Today, we're actually here to talk about S3 tables with a good friend of the program, Aditya. Please say hi, Aditya, and let us know what your favorite type of pie is.
Hey, everyone. My favorite type of pie is a key lime pie.
Oh,
yeah.
A key lime pie. That's a good one.
That is a good one.
You know why?
I don't. Is this a pun?
Maybe.
We'll save it.
Okay, gotcha.
So tell us what it is that you've been doing and building for customers.
So at reInvent last year, we launched S3 Tables, and S3 Tables is something that we're really excited about at S3. It's one of the capabilities that we've had a lot of warm reception from our customers, and it's our way for customers to be able to store tabular data in S3. So, yeah.
Awesome. So I imagine the decision to go down this path and store data in a tabular manner was something customers were asking about a ton. What specifically were you hearing that led you down this path to build in this way?
So over the past couple of years, and even before that, S3 has been used for storing tabular data, and we saw that Parquet was one of the most popular formats. And so what we were seeing was customers were basically trying to apply some of the storage management capability that S3 provided and trying to make that work with the tabular data sets. And we were also seeing a rise in open table formats like Apache Iceberg picking up steam among our customers. And so what we wanted to do with S3 Tables was basically build some of that abstraction into S3 so that it makes it easier for customers to be able to use all of that data. And so now it's a lot easier for you to basically bring your tabular data and store them in S3 tables and within table buckets without a whole lot of hassle.
Yeah. In terms of some of like the real world industry applications, where are you seeing types of customers use this and what are they using it for?
So we see tabular data being used across a wide variety of industries. Almost every industry stores data, whether it's streaming information from websites or being able to store telemetry data from cars. And so it's almost a horizontal across all industries where basically they want to store tabular data. And this has been a trend that we've seen since S3 was launched and basically has continued to accelerate over the past couple of years. And so we think that S3 Tables becomes a general foundation for customers to be able to store tabular data in S3.
You know, we're talking about Iceberg and by all means support for it and what customers are doing is certainly titanic. But what we are also interested in hearing, we've got a poll for you folks. How many objects do you think are stored on Amazon S3 today? And while this bakes, Aditya, curious, I know we launched a lot of really good things at reInvent, but what have you and your team been up to since then?
So we've been really busy, and one of the main sort of themes that we've tried to work on since reInvent is basically just making S3 Tables more accessible to our customers. Okay. And so since we launched, we've basically we've been constantly working to expand the number of regions where S3 Tables is available. We've actually expanded the number of tables that you can store within a table bucket. And there's now an easy way for you to be able to migrate your data into S3 Tables. And there's a bunch of things that we just launched yesterday that also makes it a lot easier for query engines to basically onboard and have customers be able to start using S3 Tables. So we're super excited about all of this, and you'll see a lot more of this coming.
Yeah. Speaking of your most recent launch, yesterday I heard that there was something going on with SageMaker Lakehouse.
That's right. So SageMaker Lakehouse is now generally available, and so and specifically it's the S3 Tables integration with SageMaker Lakehouse that we made generally available. So that is going to make it a lot easier for customers to be able to create and query tables within S3 Tables, and so that's something we're super excited about. And this is along the same lines of making S3 Tables much more accessible to our customers.
Yeah.
Yeah.
Awesome. I would love to see this in practice in a demo if we can jump to that here in a sec. But you did also make mention about querying. Is it specific to AWS native stuff, or are there any integrations that we're wanting to talk about?
So we've basically had a whole host of partners that basically have onboarded to supporting S3 Tables.
Okay.
And to mention a few, it's Starburst and open source Trino. We have support for reads from DuckDB. Snowflake now supports S3 Tables through the SageMaker Lakehouse Iceberg REST catalog endpoint, and a whole lot more. And we're going to continue to have more of these partners be enabled to use S3 Tables. And a big part of that was one of the capabilities that we launched yesterday, which provides a lot easier way for partners to onboard onto S3 Tables without having to do a whole bunch of work on their side. This is the Iceberg REST catalog endpoint that is now supported on S3 Tables, in addition to the Iceberg REST endpoint that is available for customers on the SageMaker Lakehouse endpoint. So
yeah, I was really excited to see those partner integrations and going through the list. I saw, like you said, Snowflake, Starburst, Dremio, DuckDB, Daft. Like, it just keeps going, right? HighByte, PuppyGraph, Stream Native, and then DuckDB.
That's right, and many more. And we'll see DuckDB in action today as well.
Yeah.
So,
awesome. You said action. I would love to see this action put into practice if we could.
All right. Cool. So right now what I have is basically the S3 Tables UI, where you have the table buckets page. And one of the things that we've done is actually updated some of the work that we're doing behind the scenes to integrate S3 Tables with the AWS Analytics services as part of the SageMaker Lakehouse GA. And so in this case, what we're doing is we've made some improvements to the performance of the integration, as well as we make it a lot easier for customers to basically have permissions be automatically set up when you're doing the integration. So we encourage customers who've turned this on during the preview to basically just redo the integration so that they can get those benefits, right? And so in here, you can see there's a table bucket that I've pre-created, and let's click in here. So this is now the list of tables. You can see there's already a table that I've populated, which we'll go through, and then there's a namespace that you can also create as part of the console.
Okay.
And so I'm just going to basically show you how it is easy for you to basically create a new table. So in here, you can select a new namespace or create a new namespace or select an existing one. I'm just going to choose the Pi Day demo one. This is going to pop you over into Athena, and here you go.
So one click in the console to enable, and you're whisked away quickly to Athena.
That's right. And so you'll see here that this is the catalog that's been populated with the table bucket, and then there's a namespace, which is the database represented here, and you can see the table that we saw earlier as well, right? So now, if I were to just basically highlight this and run this query, praying to the demo gods.
Yeah. Oh, you didn't do the dance.
Oh.
The dance could take any shape or form. It's open to interpretation.
That's right. As long as the gods are pleased.
Yes.
All right. So you see the daily sales table that we just created in the Pi Day demo database, and then you have the schema as well. Now, the pre-canned queries within Athena allow you to also populate a bunch of data in here with a sample query. So you can just basically select that and run that as well.
You know, something that I made mention in our previous session, and I have a feeling I'm going to be talking about this a lot today, is the simple idea of being able to maintain context as you go is so important to save time, frustration, and to make sure that you're not having to effectively create a giant buffer of clipboard content to be able to carry forward. And just for the regular admin or dev in their day-to-day, this is huge.
Totally. This is a huge simplification for customers to just get started and try out S3 tables, and that was our goal here. So I'm just going to pop back over to the table buckets list page, and you see that's the new table that's arrived here that we just created. All right, and now you can actually also go and click on that and query this table here. So you see there's just a select query out here populated, and if we were to run it, it should show you a sample of.
And while this cooks, chat, let us know what you want us to look for. Or if there's a specific product category you think that you personally would either go out and purchase and go out and start acquiring more. Me personally, I'm a bit of a monitor snob. I love my 4K high refresh rate resolution. But then again, I also pretty bad gamer. So I like to see myself fail utterly and miserably in 4K.
All right.
So what have we got here now?
Cool. So this is basically what you can do within AWS. I'm going to also show you how easy it is for you to basically use DuckDB as a way for you to query all of this data, right? So DuckDB actually just introduced a brand new UI, which makes it a lot easier for you to basically have a notebook interface to do all of these queries against the tables that you've created. And they also support now the Iceberg REST catalog for you to be able to read the data both through S3 tables and through the SageMaker Lakehouse endpoint, right?
Yeah.
So this is their brand new UI, and so all I'm doing here is basically just using my credential chain, which is a set of credentials that I've set up to basically get DuckDB set up, and then after that over here, you'll basically see the demo table bucket that we had. I'm just going to attach that to DuckDB.
Just like that.
Just like that.
Wow. Was there a ton of setup that you had to get going to really get to this point, or was it pretty intuitive?
Not a whole lot. I just basically on command line, which is not seen here, it was just DuckDB minus UI, and you just get it done. And as long as you have your AWS credentials set up, you should be good to go.
Awesome.
And then I'll just hit run on show all the tables.
Okay.
All right, there's some of the DuckDB tables that get created as part of the notebook. And then you see there's the daily sales table that we just created.
Okay.
And then there's also the other table that we had with the trip data that I had pre-populated before. So now it's going to be easy for you to just basically run a query to look at the trip data table. That table basically has 3 million rows, so I've just limited it to 1,000 so that it doesn't take forever.
But even that just took fractions of a second anyway.
That's right. That's right. And you can see a bunch of neat visualizations for you to look at based on some of the schema that we had already set up in this table.
Okay.
This is really cool. You can actually visualize all of this. There's passenger counts.
So maintaining the context and running the queries directly from the notebook, and then being able to additionally contextualize, visualize, and then really understand and munch on the data that you're being provided. It's like the equivalent of waking up after a nap on Thanksgiving and just going to the table and serving yourself everything you want. You have everything nice and laid out, spread for you. And for whatever reason, you just bypass all the food and go straight to the desserts, because at the end of the day, this is what your average dev or DBA is going to be looking for as they manipulate and try to get to the hyper-specificity of whatever their query is going to be.
Absolutely. And all of this is running on my laptop, and so there's not a whole lot of like spinning up a cluster to actually do any of these querying operations against the table. So that makes it a lot easier for you to be able to interact with the data. We expect developers to be, some of the folks who use this a lot, just to be able to experiment with the data that they have and be able to like see what is there before they actually like take all of this and take it to production. So it makes it a lot easier for you to on-ramp onto tables and to Iceberg, and then after that, you're good to go. You basically just get this into production and start using tables.
Yeah, it's interesting you mentioned table and iceberg like that. Finding a way to collide your data into it. We have a call out for the chat from Squared 512. It's cool that everything's laid out like that so easily. I don't come from a DBA background. I come from a storage deep background and ops background, but being able to leverage something like this, getting those helper queries to go along and start working with stuff, you're making it very approachable and less scary and daunting for the average individual to go and interact. And this is pretty fantastic. Kudos.
Absolutely. And in addition to this, it's all the partners that we talked about earlier as well, where now basically we're expecting a lot of these query engines to, we made it a lot easier for them to basically use S3 tables. And so whether it's Trino, Pi Iceberg, we already had support for Spark and Flink. We expect it to become a lot easier for you to use and bring your existing pipelines over and start using S3 tables and take advantage of the automated maintenance that we do in the background, the better performance from the higher TPS that we have for table buckets, all of that. Right?
Yeah. So I want to go to this, but I want to remind everybody we are live. So if you have questions for Aditya along the way, we're happy to get those answered for you. We're monitoring the chat the entire time. But Aditya, you mentioned working with these partners and these building these integrations together, right, to serve our AWS customers' needs. But what's it like working with AWS partners?
It's a joy, and I think one of the things that we've done consciously is basically right after we launched S3 tables, we've been keeping our head to the ground, listening to them, and trying to figure out what is the best way for us to make S3 tables accessible. And so we heard that feedback loud and clear, and so that's why we basically added a bunch of capabilities. Some of the things that we talked about in terms of the additional support for the number of tables that you can create, more regions, all of that is just basically coming from partners and essentially end customers that are also talking to our partners, right? So how can I use my existing data sets or query engines against the data that will sit in S3 tables? And just having those options be available is basically, it's been a joy.
Yeah.
Yeah.
That's good.
Awesome.
Oh, what's this?
Looks like I have got a Pi hat just thrown to me. It doesn't exactly fit, but we'll make it work. And ironically, this is probably like a 2X, but I have a giant lollipop head. But also, speaking of large unwieldy things, we have a question for the chat regarding what is the advantage, in your opinion, Aditya, of using DuckDB versus Athena for querying the S3 tables in this manner? It's a little unorthodox, but I do appreciate the question.
Yeah, no. DuckDB, like I said, just makes it easy for you to get started. And you basically don't have you have everything locally within your client, within your laptop, for you to just basically experiment with that data. Athena is basically a full-featured query engine that allows you to be able to do that in the AWS environment, right? So, and specifically with Athena and the integration that we've built, it is using SageMaker Lakehouse as sort of the unification where it has a view of all of the data that's in your S3 data lakes as well as your Redshift data warehouses. And so from that standpoint, it basically makes it a lot easier for you to interact with the data regardless of whether it's in a single bucket. So with DuckDB, as I showed you, the idea is it's an easy way for you to like connect to a bucket and start interacting with that. Athena basically sort of expands that out further and makes it a lot easier for you to like look at the entire data estate that you have in AWS.
I love that. That's a very detailed explanation, and it helps like bring further along the journey. What we also just did was drop the user guide into the chat there. And if you don't know, all of our documentation across AWS and user guides just got a major upgrade. So the navigation is a little bit easier. We've done that based on customer feedback. So it's I would say it's a much better journey to go through that. And Adrian, you were not going to be the only person with a Pi hat.
I see that. And if we were taking free throw shots, I'd say buckets for you. But I digress, folks. Earlier, we had a poll question. Would love to pull that up and see where we're at. How many objects are stored on Amazon S3 today? Jasmine and I kind of know this answer, but yeah, you nailed it. More than 400 trillion at this point, counting. And I wonder how many of them are my own memes and pics of my dogs being silly, as they are wont to do. Aditya, thanks so much for hanging out with us today. Is there anything else you'd like to drop as a parting bit of wisdom for chat and for anybody else watching?
So stay tuned. There's a whole bunch of content out here with the SageMaker Unified Studio, which sort of builds on top of what we've built, uses the SageMaker Lakehouse capability, and you can now use SageMaker Unified Studio as sort of a very powerful way for you to look at all of your data as well. So, yeah.
Awesome. Thanks, Aditya. We saw another question in there about the partner integrations. We'll see if our product teams can get some information to drop here in the chat for our Twitch followers about that. But stay tuned. We'll be back. Watch these customer stories, and we have more content coming to you live.
Enterprises worldwide trust Amazon S3 to store vast amounts of tabular data in their data lakes. This data fuels analytics, machine learning, and innovation across industries. However, securing and managing this data efficiently at scale requires building complex systems that can be costly and complicated endeavors. Introducing Amazon S3 Tables, purpose-built to store tabular data. Create, secure, and manage tables in just a few steps, and get optimized performance for analytics and machine learning workloads. Boost performance and optimize costs with storage built for tabular data. Experience higher transactions per second and better query throughput compared to unmanaged tables in storage. Store and manage tabular data in S3 with table-level security controls right from within the storage. So you can define once and apply permissions across a wide range of query engines and applications that access your tables in S3. Simplify your data lake with fully managed tables that require minimal setup and no additional infrastructure. Automatic table maintenance enables compaction and snapshot management by default, making data management easier as you grow. Amazon S3 tables simplify data lakes at any scale, helping you work faster and smarter. Get started with Amazon S3 tables today.
Hey, folks. Thanks for continuing to hang out with us today on AWS Pi Day 2025. My name is Adrian San Miguel. I'm a Principal Partner Enterprise Architect here at AWS and joined still by my lovely co-host and good friend, Jasmine.
Hello, I'm Jasmine Kyles. I'm a manager of product management here at AWS. I work all things AWS partners, but today we're here to talk about something different, and we have some more guests joining us. So welcome to the stage.
Thank you. Thank you.
Who are you, and what's your favorite type of pie?
That's a trick question. Hey, my name is Pratik. I'm a product manager for SageMaker Lakehouse. I'm one of those people who like pineapple on a pie. On a pizza. So I'm guessing. Oh wait, when he said pie, I thought it was a Chicago pie. That's the first thing that came to mind.
That's a good one. So your favorite type of pie is pizza, and you like pineapple on your pizza.
Yes, I'm one of those people.
Oh, my type of person. It's going to be very controversial in the chat because it always is.
It always is.
Welcome, Pratik. Who else do we have here?
Yes, I'm Sandeep. I'm product manager of Lakehouse, and I like pecan pie. Traditional.
Okay.
With ice cream or with whipped cream?
With ice cream and all the toppings.
Nice. Awesome. So you've already given it away. You're the SageMaker Lakehouse team. So tell us about SageMaker Lakehouse and what you've been doing with customers.
Yeah, sure. So SageMaker Lakehouse launched last year at reInvent, and it is a unified, open, and secure lakehouse for all your data and AI applications. So we have been on a journey of introducing new features since last year. Sandeep, do you want to talk about what we're doing today?
Yeah, so today we are really excited to talk about the launch of S3 tables integration with the Lakehouse. So now just a single click of the button from the S3 console, you can now go to the SageMaker console, and SageMaker Lakehouse allows you to kind of look at all the S3 tables data and join those with the data from other sources. And we are also excited to launch 2 new additional data sources. So those are the SQL Server and the Dynamo Document DB. The customers have been asking us to support more data sources, and we are excited about these 2 data source launches as well.
Yeah, that's exciting. I love hearing about, what it is that you've been doing and how this launch has gone since reInvent and how it's continuing to evolve. But we have a poll for you. So if SageMaker Lakehouse was a superhero, its superpowers would be... So select an answer for us, and we'll come back to it at the end.
I have an idea of what it would be. It would be, knowledge and connecting everything together. We keep hearing about adding different data sources. Customers have been very clear that they want to use this as their, the mythical single pane of glass, but we're getting a lot closer to making this a reality. Is that about right, gentlemen?
Yes.
Awesome. I kind of have a bit of a sharp opinion here. But for the sake of chat and for everyone else, what were the challenges that helped guide you in this direction, and specifically working with these sorts of data sources? Really wanting to hear the challenges that folks are having with what is really, as best described, as fragmented and kind of just scattered to the wind sorts of data sources.
Yeah. So, up until this launch, when we speak to customers, they would tell us that they have data in their data warehouses, in data lakes, in external databases as well, operational stores. And putting together an analysis would take a lot of differentiated heavy lifting. So they need to move data from one place to the other, manage ETL pipelines, and all of this the time to value for some of these analysis just keeps increasing. So that's the first customer pain point that we wanted to address.
Okay.
Bringing down that cost of operational burden and reducing that time to value. And secondly, making sure that data is always open, accessible from an open interface, and a single governance layer manages data access to all tables that is there in the Lakehouse.
That is fantastic. Something that you made mention, and something I get a lot of questions about, do you actually have to move your data to the Lakehouse to use it?
No. So
elaborate.
Yes. So that's one of the key value props for this for the Lakehouse. So the data stays where it is. So take, for example, Redshift. You have production warehouses for your analytics workloads in Redshift. You can keep those tables in Redshift today, but only copy the metadata into the Lakehouse. So when you're analyzing your Redshift tables, the data stays where it is. but all kind of encapsulated within the Lakehouse.
Yeah, and just to add, with this launch, we expanded the scope, right? So Lakehouse typically means your data lake, the kind of part of the lake, and then house typically means warehouses. We have expanded it to cover a large number of data stores that customers have. Like they have, data in DynamoDB, MySQL, Postgres, and we added a support for those, including the two new ones we added, DocumentDB and SQL Server. Also the third-party sources, right? So their data could be in Snowflake, could be in BigQuery. So as Pratik mentioned, the data stays where it is, and we provide the kind of unification for the engines to access those data and start querying and joining and really getting the insights from the data wherever it is.
Yeah, I love that you can get the insights from multiple data sources where they already are today. And,
Exactly.
that helps speed up productivity. You're not having to say, oh, I need to move it here. I need it in this format and all of that. So, can we see some of this in action?
Absolutely, yes.
All right.
So what are we going to be talking about? What help set the stage for chat and for folks in the audience that may be coming in a little bit cold or never heard of SageMaker Lakehouse?
Yes. So, just a quick recap. SageMaker Lakehouse is the unified, open, and secure lakehouse for all your data and AI applications. And we're going to be looking at one of those examples. We're going to take an example of CarCo. We have all bought a car at some point in time, and we have all been part of a marketing campaign where someone's selling us a car. So we're going to look at, behind the covers, how that marketing campaign is put together.
Would love to look at it.
Yes. So what I have here in front of me is the SageMaker Unified Studio, which was also made generally available yesterday. This is the unified development experience for both data and AI in AWS.
Okay.
And I'm going to walk through three personas here. So Alice, Bob, and Charlie.
Okay.
So Alice, Bob, and Charlie, all three work for CarCo. Bob is the marketing analyst who needs to put together a marketing propensity list. Alice is the data admin.
Okay.
And Charlie, I'm going to let Sandeep talk about Charlie in a while. So,
okay.
So what you see here is, a view of what Bob would, see when he logs into SageMaker Unified Studio. He has a project. He goes and clicks his project. And then he has access to a few resources within the project. Of interest here is a marketing propensity list, and this is an analysis that he needs to put together. Well, he has access to customers table in S3, but he needs access to tables in Redshift, and he needs to reach out to Alice. He wants to query both S3 and Redshift tables all within this one unified studio experience, and you can see Lakehouse right there, where it catalogs all your data sources all within that single pane of glass. So let's, we'll get back to Bob in a while. Let's go back to Alice's view. Alice today is the data admin who manages data in Redshift in S3 for CarCo. If you kind of log back into Alice's experience here, there are multiple namespaces in Redshift that she manages. Of interest here is Car Sales DB, which she wants to share with Bob. With a single click of a button, she can register it to the Lakehouse.
Easy as pie.
Easy as pie, right? Once registered to the Lakehouse, it shows up as a pending invitation, and Alice can go in and approve that as a catalog. And you can see here there are multiple pending invitations which you can choose. Once it is accepted, it shows up as a catalog. Now, a catalog can have multiple tables, right? Now you have supplier information, sales order, customers, but Alice doesn't want to share all of it with Bob today. She probably would want to only share sales order and car for the analysis that Bob is conducting.
Yeah. And chat, let us know what your first car was, if you had a car. Mine was a 97 Cavalier, and it was a hunk of junk, but sorry, I digress.
And so the final, I think the secure benefit that we were talking about in Lakehouse is you can grant fine-grained access controls over your tables to, like a persona like Bob. So in here, when you go to data permissions, you can select the catalog, the specific database, and all the way to tables and specific columns that you want to grant Bob access to. So here what we can see is Alice wants to only provide select and describe access to the two tables that Bob asked for. And again, once you click grant, all of those show up under sales schema in Bob's view. So I'm back to Bob's view here, And these are the only two tables that he can see. Now let's go back to his marketing analysis. We see here car data, which is part of the Redshift namespace. And Bob does have access to it. Yes, the demo gods are with me.
You didn't do. We keep tempting the demo gods, and we're not doing the dance. All right. Before you go, Cindy, we need to see the dance. We're getting away with it. It's just working.
Yeah, Chad is saying it's so great to be able to access all of our data in one place.
Yeah. Now this table here, customer table. If I recollect, this was in S3, and whoops. Oh, wait. I only selected customer there. I should select the whole query.
I was about to say, that's what happens for not doing the dance.
There you go. And yes, and finally, I think this is where the magic happens. We talk about bringing together both the Lakehouse and tables in S3 all in one single place. And with a single join of tables in Redshift and S3, Bob can now put together the marketing propensity list for the marketing campaign.
You know what this reminds me of? Speaking of putting all of these things together, it's like bringing all the ingredients together when you make a pie.
Yeah. It's a recipe for success. It was right there, Jasmine.
A recipe for success. Let's rewind, cut that part. Just kidding. We're live. So let us know what questions you have for us while we're going through these demos here. So we're bringing all of this information together like ingredients.
Yes.
In this case, it is, the sales data, the car data, the marketing, what's in the catalog, and putting together this marketing campaign.
Yes.
Okay, that's awesome.
Speaking your language, Jasmine.
It is.
So
all
what
right,
do we got
what's next?
Yes.
All right. So yeah.
Switch it over to Sandeep.
So now that Alice has got the warehouse data in the Lakehouse, she also heard about this new thing called S3 tables, and she knew that this is a great way to kind of have the clouds object store with Iceberg, and she decided the customer 360 data should be in the S3 tables. So all she has to do is go in the table buckets and click on this enable integration. This is the GA general availability that we launched today. So enabling integrations allows anyone to get access to this data in the Lakehouse. Through the different analytical engines including Athena, Redshift, EMR, as well as third-party engines. So in this case, Alice goes and clicks on the enable integration, which I already done. To get it in the SageMaker Studio, she has to do one more thing. She has to go in the SageMaker Studio and create a project, right? So she knows that Bob is from the marketing team, so she created a marketing project. She knows the Charlie, who's a new persona we'll introduce. He's a sales guy, so we created a sales project. Alice created a sales project for him. And then the third thing she has to do is provide access to particular project, right? So she goes in the data permissions, which is the admin console, and she provides the access. In this case, you can see that she provided access to this particular marketing. She can do it at a catalog, database, and even something like sale filter. That means she can do it at a column or row, even at a cell level.
Interesting. It actually plays right into a question we got from the chat. Would it make sense to choose SageMaker Lakehouse if the enterprise is looking for a centralized data layer with centralized governance instead of a data mesh or a data fabric? Is that about right?
Yeah, absolutely. So the SageMaker Lakehouse is a combination of bringing your data lakes, whether they're in general purpose buckets, whether they're in the S3 table bucket, S3 tables. So you can create the data mesh using Lakehouse. And the good part is now you can also bring the warehouse information as well as the different data sources in. So yeah, it brings the data mesh plus to this.
Yeah.
Awesome, thank you.
And you can share the data with other accounts. So we have been sharing it with Bob and Charlie, who may be part of the same account, but they very well could be in a different account. So that's the vision of a data mesh, where you could have multiple accounts that you want to share data with.
Yeah.
All right, so going back to the demo, so now that Alice has got the S3 tables in the Lakehouse and added Bob to the marketing project, Bob is super happy that now he has like a unified view of all the data. Like he can see the data of S3 tables right here. He can go and there's a query that I wrote. I'm just going to run all here, and then he can see the data which is even from Snowflake all the way to the Redshift to the DynamoDB, MySQL, Postgres, and a lot more. Right, so that's available to the Bob, and Bob can see that the data that from the customer that Alice created, customer table, is already available to him. If that includes the customer information, he's more interested in the information like customer service request, right? Because he wants to know, okay, what happened with the service records and if there are any issues with the customer. But this table does not tell which customer it is, right? So it's not actionable. So he has to join this data in DynamoDB with the data in the S3 tables. And that's the query he wrote, which allows him to see that, okay, Alex Smith is probably the person who has a lot of issues here.
That kind of looks like my truck service history, I'm not going to lie.
So being a good marketing person he needs to kind of go and give some coupons, marketing coupons, and keep Alex in the fold, right? So the value of it is kind of bringing the different data sources and generating insights from it, right? Which was earlier not possible. Let's go to the last persona, which is sales persona, right? Like if we go to Charlie, right? Charlie now has been added to the sales project, right? So you can go to the sales project, like how Charlie will go and see it. Now, when Charlie goes to the Lakehouse, he sees only some portions of the Lakehouse than Bob, right? Which is because Bob has access to a lot more, but Charlie, being the salesperson, may not need all the marketing-related information. So you can see that, okay, I'm going to run the query here, but you can see that, okay, he can see the customer, right? And he can see the customer service request, but Alice has decided maybe Charlie just need access to name and email. It doesn't need access to, the age and address.
This sounds a lot like role-based access control.
Role-based, column-based, cell-based, exactly, right? And then but then same power applies. Like Charlie can go and join the data from the, again, customer service request and find that Alex Smith is still the guy. He needs to go and make sure sell, right? Yeah. And so he was able to find the email, find that information about like what kind of problems he's facing and whether we handle that, and maybe there are some things which are pending. And it's probably Charlie needs to call Alex, right? Make sure he's
happy. He's happy and his transmission doesn't fall out.
This is probably the last question that we have time for, but Squared512 asks, so it can help track behaviors or login issues for the customers?
Yeah, so the customers can create the tables and start kind of look at those tables and kind of understanding the changes. We didn't talk about this, but we have in Lakehouse, we earlier talked about S3 metadata, where it is the things are changing. Those show up in the Lakehouse as well as the Iceberg tables, right? So customer can look at it and see the data changes.
Yeah.
Awesome. We're right about at time, gentlemen. But before we go, is there anything else that you'd like to leave at the chat to go and get started, some advice, where to potentially go look up some more information?
Yeah, there are a couple of great blogs that have gone out this week. So how do you get started with S3 tables, with the Lakehouse, and many other third-party engines that you can now connect to. So we do recommend go check out those blogs.
Yeah, and just today we launched this news blog which shows the integration. The demo that actually I showed is available in the blog. You can go and try it out.
Yeah. Awesome. Well, we're going back to the poll here. Let's see what the answers were.
And we see all of the above. Great. GG's chat. That's pretty much exactly what we were looking for. But we're about out of time here. Thanks so much, gentlemen, for hanging out with us today. Folks, stay tuned. We've got some more great content for you. Don't go anywhere. I know I won't be.
Our challenges are very consistent with the challenges other business organizations face, which is how do we take friction out of the way we operate? After we switched over to Amazon Redshift, we saw significant improvements in our SLA deliverables, like about 18% improvement with our service levels. Our disaster recovery and business continuity plan are much more robust. With this switch, we've seen close to 35% reduction in our operating cost. We want to pass on as much value to our customers, and taking cost out of business, one way to do that. Also, just keeping up with the innovation. The solution that we have is one of a kind. It's a functionally rich industry leading data warehousing solution where we have a single source of truth that allows business to understand how it's performing. It provides the pulse of the organization. With all the innovation that's happening with the Amazon to interact with various Amazon Web Services, Redshift, and the SageMaker Lakehouse, it makes the developer experience that much more better. It also improves speed to market because you don't have to jump across multiple services. The features like Amazon Q Developer is something very exciting, and we want to explore that further and see how that will help us improve our developer productivity and our speed to market and build better quality solutions.
Welcome back to AWS Pi Day. It is our 5th anniversary of this broadcast that we're doing here on March 14th. It is significant in so many ways. It is Amazon's S3's essentially the birthday, right, of the first time that it was made generally available. And so we're taking you on a journey here of showing you kind of like where we've been and where we're headed. And so right now we're back with another session. I'm Jasmine Kiles. This is my co-host, Adrian San Miguel. And we want to know in the chat, what is your favorite Pi Day tradition? Mine is probably going to be this hat for a very long time. It's the 2nd year in a row wearing it, but I'm excited to hear what it is. I've heard of a lot of different traditions that might happen here, but that's not all we're here for today. Adrian, what do you think we're going to do next?
I don't know, but I have a pretty good inkling that it's going to be both delicious and filling. Don't have a specific Pi Day tradition, but I think I'm always going to remember wearing this hat. And I think I'm also going to remember some of the stuff that we're going to be talking about today. And most of the things that I deal with and have strong opinions on with my partners is data security and governance. And I understand we're joined by a guest today that's going to help us talk about exactly that. So if you wouldn't mind, sir, say hello, what your favorite pie is, and why you think pineapple belongs on pizza.
Hello, my name is Utkarsh. I'm a product manager at AWS, and my favorite pie. I think I'm a very. I do a lot of experiments in life, but with pie, I don't do any experiments. So my favorite pie is good old apple pie.
Oh, that seems to be a favorite. Like, there's been at least 3 other guests who have said apple pie. It's a classic.
It is. It's a split loop. It's 3.14 and counting. I'm sorry.
Utkarsh, so tell us what it is that you're going to be talking about. What do you do at AWS, and what do you do for customers?
Yes, I'm a product manager at AWS. I'm part of the SageMaker Unified Studio team, and I focus on SageMaker Catalog, which basically forms the foundation of data and AI governance within SageMaker Unified Studio.
That's awesome. Chat, we got a poll question for you. What is the primary use case for SageMaker catalog. And Utkarsh, I'm sure you're going to tell us all about it.
Absolutely, yes.
So curious, what have you been hearing from customers that has kind of guided the way that you're thinking about going out and solving this problem? Because obviously there's going to be a ton of different ways to go about it, but really, really wanting to understand how you and your group are putting thought into practice here.
Absolutely. So when we talk to our customers, right, the first thing that we hear is we have data, so much data, and it's everywhere and scattered across so many different silos. And today it's not just data, right? It's also your AI and machine learning models. It's also your GenAI applications now. How do we enable our data scientists and analysts to find all of these assets? And how do we enable them to access them and consume them without slowing them down, but at the same time making sure that we are not compromising on governance?
Yeah. That's so interesting to me. So one of the things that we just saw in the session before this was about SageMaker Lakehouse. So how is SageMaker Catalog different?
Yes, SageMaker Catalog and SageMaker Lakehouse are slightly different, and I'm going to explain. So let's take an example. Let's say you have some data in your Amazon S3 bucket, and you want to query that data using one of the engines, let's say Amazon Athena. Now, Amazon Athena cannot go and directly query this data in S3 in an S3 bucket. What Amazon Athena needs is some configuration. Lakehouse provides that configuration, and essentially it's the technical metadata like your table name, your columns, your data types, as well as the permissions, whether the user who's trying to query this data, do they even have permissions to access the data in Amazon S3? So that's what Amazon SageMaker Lakehouse provides. And what SageMaker Catalog is, it provides a layer above it, and it allows you to add business context to your technical metadata.
That's fantastic. Is you can really kind of contextualize it and think about it as the governance layer directly interacting with the data as it needs to, so that thinking about it in a very broad sense of term, only accessing the things that matter to the business in the way that they need to be accessed in a way that's defined safely with guardrails. Is that about accurate?
That's absolutely right.
That is quite radiant if you think about it. That is just beaming with possibility, and kind of giving folks the warm fuzzies around how you can protect the estate while just giving folks exactly what they need access to.
Exactly, right? Like with what SageMaker Catalog allows you to do is enable discovery on top of your data. You have data across so many different silos. You can bring all of them together into one place and define business context, like your business descriptions, not just scriptive column names, but also your descriptions and your data lineage and data quality, things that help you build trust in the data, and then be able to access that data in a self-service fashion.
I like what you called out there. We tend to be, as tech practitioners, thinking about things in terms of security by obscurity, which really isn't the best way to do things anymore. I really like the way that you put that, Utkarsh. I think that's going to resonate with chat for sure, and with any of our data and analytics practitioners out there. So, it kind of leads me to the next question. How does it work? Is there a demo that you can walk us through to show us, practice in action?
Absolutely. Let me show you a demo.
Okay, please.
And I actually have a demo which exactly shows you what we've been talking about. So here I have a use case, a very common use case where we have a data analyst. He's part of, his name is Bob. He's part of a retail organization.
Oh, that Bob.
Bob is famous today. So he's part of a retail organization, and he has been tasked to do an analysis on the performance of individual stores within that organization. So Bob has access to some data. So let's see how Bob does that analysis using SageMaker Catalog and SageMaker Unified Studio, right? Here I am logged into my SageMaker Unified Studio. This is the home page. I'm going to select a project to start with. This is a sales analysis, so I already have a project called Sales Analysis. And what this project is, just to give our viewers a little bit context, it gives this SageMaker project is essentially how you work with data in SageMaker Unified Studio. Project gives you access to data and access to tools and compute to be able to work with that data. And you can collaborate using a project. So you could have your data analyst, your data scientist, your data engineers all working in the same project with consistent access to data, but they could be using the tool of their choice.
Okay.
Right? So like a data engineer could be using ETL Visual Builder, or a data scientist could be using a notebook to build machine learning models, or a data analyst could be using a SQL editor. So let's take a look at the data tab. And what we can see here is what all access does Bob have. We can see that he already has access to some of the tables. For example, he has access to store locations, which would be very important for him to do this analysis on store sales. But what he doesn't have here is any sales data or anything that's related to transactions that can help him figure out how much revenue each store is making.
Yep.
So let's see how we can go and find this data in SageMaker catalog.
Okay.
Yeah, we talk about your analysis only being as good or as high quality as the data is. So yeah, let's
exactly.
Jump.
So we'll go to the catalog and we'll write a simple search using a business term like sales.
Okay.
And you can immediately start seeing search results. So let's click on the first data asset. And what you're seeing here is there's a lot of metadata here.
Okay.
Right? It's not just the technical name of the table. It also gives you what kind of table it is. It's a table in the Glue data catalog, and you can see that there's a big summary here.
Can we get a little bit more of a zoom on that, please?
Absolutely.
Okay. A little more. I think that's good. Thank you.
Great. And you can see a lot of summary about like what this table is about, what kind of use cases does it solve. So the owner of the data has put in the effort to put all of these details into the catalog so that when someone is looking at this data in the catalog, they can understand this data really, really well.
Yeah.
And they can use it properly in their analysis. You can see a README section and a bunch of technical metadata as well, which would be very important for Bob to be able to write a query correctly. And if we go to the schema tab, you can see that there's all the columns are specified here, but not just the names of the columns. There is also business names and descriptions, right? Another thing that you would see is Bob can also look at the data quality. This is what helps him build trust in the data, right? So he can see here that this data asset is checking all of the boxes when it comes to data quality, be it completeness, uniqueness, or the column count. And if Bob is interested, he can actually look at all of the different data quality rules that have been configured by the data owner. So they can look at each rule and whether this data asset is passing on those rules or not.
And that was going to be my question. Is that something that the consumer of the data is going to have to go and establish? But no, it's more the publisher of the data that's going to go out and define exactly what these parameters are.
Exactly.
Okay.
Exactly. And another thing that you can see here is data lineage, which basically tells you how this data asset was generated. What is the underlying data source? What kind of transformations it went through? So, for example, what you're seeing here is a graphical, a very visual graph where you can track the entire data lineage, upstream lineage as well as the downstream lineage. So, for example, what we are seeing here is that the source of this asset is an Amazon S3 bucket.
Okay.
If you go to the next node, you can see that there was a glue crawler that ran that registered this data, this table, into the Glue data catalog. And then if you go down further, you can also see how it got into the SageMaker catalog. And then there are some other projects who are accessing this data.
Yeah. So I'm able to see who did what and when.
Exactly.
Yeah, no more guessing where the data came from, no more guessing on integrity or, in a lot of specific business conversations and context, chain of custody becomes a very big thing. And being able to have an immutable record of that is huge.
Exactly, and it's also about like as a data consumer, when I'm trying to access some data, I want to know like if there is a data pipeline, is there something broken in that pipeline?
Okay.
Right. Data lineage helps you identify that.
Okay. Nice.
So now that I have found this data asset and I think that this is the right data asset for my analysis, how do I get access to this? It's very simple with SageMaker Catalog. You can just simply hit the subscribe button. You can select your project, which is Sales Analysis Project, and just provide a reason. Here I'm just going to say for demo and request access.
Yeah, and while this cooks, looks like we've got a comment from the chat. Manish Kumar from LinkedIn is saying it's the first time he joins Pi Day and believes that Jasmine should ditch the hat. I think you should not.
I don't plan to ditch my hat, but thank you for being here.
This looks like it's done baking, Utkarsh. So what do we got now as our next step?
So now what has happened here is that SageMaker Catalog has sent this request to the owner of the data.
Okay.
So let's switch into the shoes of the owner of the data. So I'm going to switch into a different tab. Here I have a different project selected. This is the project that actually published this table to the SageMaker catalog. And now if I go to my subscription request tab, I can see that there's a pending request here. I can look at this request. And now I can see who has requested access. I can see from what project, for what reason are they requesting access. And now I can approve this request. And when I'm approving this request, I have two options. I can approve this with full access. What that means is the subscriber is going to get access to the entire table, all the rows and columns in the table. But in this case, I know as a data owner that this has some sensitive data. This has some personally identifiable information about customers, and I want to hide that information.
Okay.
So I can approve this with row and column filters. I'm going to choose a filter, and I can create a filter here. I'm going to show you how to create a filter to sort of restrict the access to certain columns. So I'm going to call it no sensitive data. And I can select a filter type, which can be either a column or row filter. I'm selecting the column filter. I'll just select this checkbox, which selects all the columns, but then now I can hide some of the personally identified columns. Like I can remove customer name, email, phone, and address. Those are the columns I don't want to give access, and I can just simply create the filter.
And this is huge for ensuring, principles of least access, ensuring role-based access controls are still a thing, making sure that people only have the bare minimum amount of access to do the thing that is required for them to go and execute their job and succeed at the task.
Exactly. And what SageMaker Catalog does is it kind of abstracts the technical complexities involved in creating this fine-grained access control. You saw how visually how user-friendly the interface was, and it's the same interface across, irrespective of where your data is. It could be in the Lakehouse, it could be in Redshift, or any other data source. You will create this column filter or row filter exactly in the same language that you saw on the screen.
All right, we're getting a lot of questions in the chat here. So is the lineage generated in an automated way?
Ooh.
Yes. That's a great question. Yes, lineage is generated in an automated way for some of the sources. For example, lineage from Glue Data Catalog, lineage from Redshift, lineage from Visual ETL Flow. All of that can be captured automatically. And so when you are publishing your asset to the catalog, SageMaker Catalog does the work of fetching the lineage, so you don't have to worry about it.
Yeah. Someone says, oh, this is great with compliance and governances.
I'm glad they feel that way. And that's exactly the goal of SageMaker Catalog.
Yeah. Can a custom meta model be defined for metadata?
Oh.
Yes, absolutely, it can be defined. It's a completely open catalog. So we have the way it works is that we have certain types of asset for which we have some metadata that is predefined. For example, if you're looking to publish a table in the Lakehouse, there's metadata that comes out of the box. You don't have to worry about that. But on top of that, when you want to add business metadata, you can define what metadata you want, because that varies across the organization, right? Some organizations different organizations have different requirements from a compliance and governance standpoint, and they can build their own metadata model.
Okay.
Fantastic. All right. So what's the next in the demo?
Right. So now we are back to that screen where now I can see my no sensitive data filter. I can select that and approve the access.
Okay, and while this is going, wow, okay, never mind.
It's just 2 seconds. And what happened here, just to help you understand, is that SageMaker Catalog, once the subscription is approved, SageMaker Catalog can go into the underlying system. In this case, it's the SageMaker Lakehouse, and create physical grant on behalf of the data owner. So they don't have to go and work at the technical layer. So now if we go back to our project where Bob was doing his analysis, and we go back to the data tab, what we're going to see that the sales data table starts to show up. And if we click on this, what we'll see is that all of the columns that were given access to, Bob can see those columns here. And if you should note that the personally identified columns like customer name and email, those details are hidden. So all Bob can now do is he can choose the tool of his choice. In this case, we're going to use Athena to query. And what it does, it opens Amazon Athena in the SQL editor, and Bob can just simply start querying the sales data table along with all the other data that he has access to from within SageMaker Unified Studio. So here we ran a simple query that queried the sales data. And if you want to run a query that joins the sales data with other tables, we can do that as well.
Yeah, you guys, we're coming to the end of our time here. This demo, I love seeing it. I want to see more. How can I learn more?
You can learn more by going to the AWS console and get started with Amazon SageMaker. All you have to do is create a SageMaker domain, and it literally takes a minute to get started.
Okay. Nice.
Well, that is pretty fantastic. And chat, folks, we want to check in on that poll that we had. Primary use case for Amazon SageMaker catalog. We can bring that up. Both. All right. Yep. That is absolutely correct. Thank you for your participation, chat. And Utkarsh, thank you so much for joining us today. Really appreciate what you've shown us. We got a lot of people excited about the art of the possible here for data and AI governance. And please stay tuned. We've got a lot more exciting stuff.
While you're waiting on us to come back for our next one, we have a chat. So speaking of getting started, if you take our survey, the first 100 people will get $25 in AWS credits. And hey, maybe you can go in and apply that to your account and start building something in SageMaker. But we will be back with more, so stay tuned.
Motive's AI Dashcam and suite of products has been shown to greatly reduce speeding occurrences, collisions and accidents, as well as other unsafe driving behavior. When looking to develop a solution with our great AWS team, we took a look at our landscape, as well as we already had Amazon Redshift holding hundreds of terabytes of our raw vehicle message data. And so how can we simplify it and what was available? And that's when they showed us Zero ETL, and that all those sources that we're already using are already available as integrations. The results and impacts were so clear from day one. The speed and latency was the biggest win for us. And in our DynamoDB world, we went from 4-hour to 6-hour sync intervals down to 30 minutes or so, reliably as well. And that was the other thing, is that we haven't had to touch it. It just works. So we're saved over $100,000 a year by removing all that data transfer, all those different mechanisms and compute for loading and just getting the data there. And we're able to now do more features, do some of our detections on a sooner cadence, all these types of things, which translates to, safer driving, and more visibility and easier compliance for our customers.
Hey folks, welcome back to our next segment on AWS Pi Day 2025, our 5th anniversary of doing this thing. My name is Adrian San Miguel. I'm a principal partner enterprise architect here at AWS, and still joined by my lovely co-host and increasingly good friend, Jasmine. Say hello, Jasmine.
Say hello, Jasmine.
There we go.
Hi, I'm Jasmine Kiles. I'm a manager of product management here at AWS. And in the spirit of Pi Day, guess what I brought?
Pi.
I brought Pi.
There
Here
we go.
This is for you.
I thank you. We're going to have a big slice of this here in a little bit. But for now, we are going to be joined by a special guest talking about an exciting new launch. So, Diane, if you wouldn't mind introducing yourself, letting us know what you do here, your favorite slice of pie, and why you think pineapple belongs on pizza.
I'm afraid I'm not an expert on pies, but
okay.
that looks delicious, though. Yeah. Hello, all. My name is Dayanand Rangegoda. So I'm an engineering leader. I lead SageMaker Unified Studio. So excited to be here.
Awesome. So, Diane, I understand you have been very, very busy working on helping meet our customers where they are. So if you let us know, we talk a ton about data being and data integrity being a good foundation for an AI strategy. Very curious to hear your position on that, and let us know what you've been hearing from customers about the challenges that they've been having lately.
Yeah, that's a great question, Adrian. So one of the main challenges that customers are having today is how easy it is for them to work across different services. AWS has been great, and there are amazing purpose-built services to get the job done, but customers have to use more than one services to get the job done. That's a little hard today, so they have to do all the heavy lifting. So Unified Studio solves that problem.
Yeah.
And the cost that is involved, time to market, and the productivity, those are some of the key challenges that we intend to solve using Unified Studio.
Especially, those are some of the things that customers really love to hear is like, you're going to be efficient with my costs, you're going to be efficient with my time, and I'm going to be able to be super productive and really collaborate across the organization.
Totally, yes. Yeah. Those are some of the key challenges.
Yeah. What were you saying, Adrian?
Data is gravity. We've been saying that for a long time, almost to the point where it seems a little cliche, but it's the truth. And especially when you have mountains or lakes or heaps of data, you can't easily move it at all. And giving access to it can also be a bit of a double-edged sword at times. So, Diane, very curious to hear how does SageMaker Unified Studio go about and solve these challenges? It's one thing to provide access to the data. It's another thing to, in my opinion, administer and moderate that.
Yeah, totally. Yeah. SageMaker Unified Studio, it's a collection of multiple capabilities that includes SageMaker Catalog, SageMaker Lakehouse. In addition to that, it offers a plethora of best-of-breed AWS tools that customers have come to love and they use for getting the purpose-built job. It brings together all the capabilities. And to your point, SageMaker Catalog is one of the foundational elements, so that enables us to govern the data better and take care of all the integrity challenges there.
Awesome. Chat, let us know if you're using SageMaker today, and if so, how? Because I think we might be getting into a bit of a demo, Diane. Is that about right?
Yeah, totally. Yes. We can get started with the demo.
Please. I mean, would you mind setting the stage and letting us know what we're about to see?
Yeah. So the background here is it's about a high school student named Sid, and he's a movie buff. And
movie buff, you say?
Yeah, he's a movie buff. He loves movies.
What is your favorite movie?
There are many, but Shawshank Redemption for sure.
Oh, that's a good one.
For me.
Okay, that tells me like quality movies. Adrian, what's your favorite movie?
Hands down, Stand By Me. Everybody knows. Anybody that knows me knows that answer, and I just showed my kids that movie a couple weeks ago. They were hooked. They didn't move the entire time.
That's warm. I like to keep it a little bit lighthearted. My favorite movie today is American Pie.
What a slice of Americana.
All right, let's get into the demo.
Okay, yeah. So the story here is Sid wants to work with his friend, Arsh, who is also a movie buff, and they want to build an application that predicts how much customers are going to love a movie by giving the story as input to the application.
Interesting. Would love to see this in action, because that's kind of a loaded statement. I would love to understand how you go about and show that.
Yeah. So I'm going to walk you all through how the journey that Sid and Ash undertook. So I don't know how much I'll be able to get to, but so the first thing is Sid has access to the URL here to the portal. So it's pretty easy to create the URL. Go to the console, and with a couple of clicks, you can create this URL. And the first thing that one needs to do here is, what Sid did here is to sign into the portal. You can use your SSO for signing in.
Okay.
These credentials are set up as part of the portal setup process in the console. And it takes Sid directly to the home page here. So I think you all have been looking at this homepage quite a bit since morning. The catalog, GenAI Playground, shared GenAI assets. Like I said, best of breed AWS capabilities, they're all found in the homepage.
Okay.
And you also might have heard about projects from our previous colleague Utkarsh, who talked about SageMaker catalogs. So the first thing that Sid has to do here is creating the project. So creation of the project will let him work on his data and then collaborate with his friends, colleagues to build the application. And yeah, this is pretty simple to create. So you can give the name of your choice. My awesome movie rating predictor.
Okay.
Right. So you can give a corresponding description like that. And yeah, the most important thing to consider here is the project profile. Project profile gives a blueprint to set up the tooling and the infrastructure that go inside the project.
So you're going to go and build all this infra, and the individual trying to consume the project doesn't have to. They don't have to go and specify.
So that's a great point. Is they don't have to specify here because it comes already pre-created, so he can just select this profile. He can choose to customize if they want to, but in this case, Sid has chosen to select all capabilities profile that spins up all the relevant infrastructure as well as tooling.
Okay.
So it's a pretty simple wizard, and you can set up your Lakehouse database name and the log retention duration. Very simple parameters. They're all pre-selected for you.
Yep.
And then you can continue, review, and submit. You're done. So in this case, it's going to take some time because project creation is going to bootstrap all the resources. So they're pre-created by Sid already. So I'm going to come back and browse the project that have been created. Movie rating prediction is the one that is created.
Okay.
This is the project homepage. You can see that everything is nicely arranged, data, compute, and members of the project. And this is the code repository information, code repository that is attached to the project, and other project details here. So the first thing that Sid wants to do is to process the data and load the data to Lakehouse. Because he can query the Lakehouse data. And it's pretty easy to query, and it gives consistent interfaces that can be queried using multiple engines. So the first thing that it does is using Visual ETL. So under the build menu, he finds Visual ETL flow here.
Okay.
So you can see query editor, Visual ETL, Jupyter Lab. There are some interesting applications. So Sid has chosen to use Visual ETL flows for the job. So Visual ETL, again, is one of the tools that Amazon has and customers know about. So it provides drag and drop capabilities for customers to create a graph and execute the graph. It's pretty simple.
Okay. But
as such, it is simple. Yeah, go on.
Yeah, this looks like you can use natural language to specify what you're looking for, so you don't have to drag and drop. So you don't have to be a data expert to be able to tell the thing what you want to build.
Absolutely. You don't have to be an expert here. So drag and drop itself is an easy way of configuring your ETL job. But in this case, it has become even more easier where you can type in the natural language to generate the DAG.
Okay.
So I'll just show you one simple DAG generation. Read data, CSV data from S3 and store it in S3 table.
And this is something that anybody in the chat can go out and kind of walk along and do this with you if they wanted to, right?
Absolutely.
Okay.
So,
and would you mind zooming in a little bit, please? Oh, there we go. Wow, that was fast.
It just created. So now all that needs to happen is just come and configure where the data is, and and just run the job. It will run the ETL job by provisioning the instances in the backend, and it stores all the data to Lakehouse.
And you don't have to be an infrastructure expert. You don't have to be a dev. You don't have to be a data scientist to get started and actually go through and do this.
Absolutely, yeah.
This is giving me some ideas. You know, you're going through the movie rating predictions, but I think I might go take all of the ingredients for all the pies and put together some kind of generator.
Oh.
Yeah, that's a good one. So I'm gonna come back and show. Sid has already gone through this process, and he has created multiple flows already, and data is already copied or moved over to Lakehouse.
Okay.
So this is the first step. As a next step, Sid wants to query the data. So he comes to Query Editor. Again, Query Editor is one of our one of the existing tools that customers can find in Redshift. So now here we're standardizing on Query Editor. Like I said, we are bringing in best-of-breed tools for customers to do their job better, while not offering duplicate tools. So when I say that, you can see that customers can either use Redshift or Athena to query the data.
Okay.
Right?
Using the right tool for the job versus, to your point, 72 different ways to do the exact same thing.
Exactly. Yeah. That is a status today, because when AWS has so many purpose-built services, it's invariable. Invariably, you will find the duplicates. But here we are standardizing here. Everything is
and it looks
under
great.
one umbrella. Thank you. So here, I'm gonna execute a query for you, Adrian, Jasmine, or the audience. Let's see. I'm gonna bring up the top rated movies. I mean, let's see.
I've got my opinions. I have very, very sharp opinions in this domain. A good friend of mine and I spent an unhealthy amount of time watching movies. Pros and cons, why it was good, what the themes, what the motifs are, archetypes, etc. So, this is kind of near and dear to my heart.
Yeah. You know what? I mean, yeah. So I'm bringing up only top 20 movies.
Okay.
So what
really? Really?
That's interesting.
Attack on Titan, the movie, is a top. No, I've got opinions there.
That's a good point. You know what I've done? I've used 10,000 as the vote, so it seems like less popular movie. So, but Shawshank Redemption, my favorite movie that appears here on top, 3 million votings. Pretty much the whole world has voted for this movie. All right. So, yeah, I mean, I can,
Oh, wow.
What I'm going to do is I'm going to increase the vote count to 100,000 so that I can filter out Attack on Titan.
No, that's good. That's going to... Oh, there we go.
Oh, there we go. Now we have some good movies
that
on
looks
the list.
a little bit better. 12 Angry Men deserves a higher rating. Henry Fonda was fantastic in that. See what I mean? You see what I mean? All this useless stuff sitting in my head at all times to have these type of conversations.
Yeah. Okay, so like I said, you can use multiple engines, Redshift, and you can also use Athena here, right?
Yeah.
Athena is another engine. So Sid has executed multiple queries here. So one of the things that Sid has done here is using unload operation. And unload would copy the data over to S3 again, so that can be taken up for further processing for machine learning and for transformation before models are built.
No, this is really intuitive and easy for folks to go through and start. I hate to say the word manipulating, but it's actually specific in a positive connotation. You're working with your data set to get the specific view of what you're looking for to better inform you to go make a decision or have an understanding of the aggregate trends that are happening in your data.
Yes, totally. And here, I will just give you all a quick demo.
Okay.
Unload curated data on Pi Day.
Okay.
Right?
Let's
so
do it.
Here it's gonna unload the data to this particular S3 folder.
Okay.
So
let's go ahead and give her a go.
Running it.
And I did throw it out to chat. I did make a horrible mistake, and I'm kind of embarrassed. Don't know why I threw Henry Fonda out there. It was Gregory Peck. Gregory Peck was the lead in 12 Angry Men.
Okay, so here query is executed successfully. 3.8 seconds. Athena infrastructure was spun up, and it queried the data, joined the tables, and the data is all copied over to S3, right?
And that
so
was,
now,
what, 3.8 seconds, it looks like?
3.8 seconds, yes.
Would have been better if it was 3.14159. But hey,
Absolutely.
who's counting? Who's counting?
Exactly. So I'm just going to show the data here.
Okay. And again, you know, just the ease in being able to browse through this and not have to switch windows, not have to change context, not have to remember the thing you were specifically doing. You get a pop-up, have to relog in, and it breaks the workflow. This is just a quality of life enhancement that the average developer is going to not only embrace but wholly appreciate.
Yeah, totally rightly said, Adrian. I mean, if you really see, okay, the data is here. Data is all dumped here.
Oh, nice.
As I
There
said.
we go.
So the point here is, like you rightly said, I use Glue, right, through Visual ETL to perform ETL jobs to copy the data from S3 to Lakehouse. And here I used Athena and I used Redshift. Everything I'm able to do from single umbrella, right?
Yep.
One tool, wherein I'm not leaving the tool. I could easily process the data, and I'm querying the data, and I'm ready to go to the next step to combine this data for machine learning.
Yeah, and like you mentioned before, this brings a variety of like roles together, right? So we're seeing it from the analysts, the engineers, the data scientists, maybe somebody who's on the front end of building the app, and you're able to bring all of these resources into one place in this project.
That's an amazing point, Jasmine. Totally, yeah. I mean, multiple users can come collaborate here, and they all find the data and resources shared as part of the project. They can collaborate very efficiently.
Yeah.
And, to that point, even the personas, spectrum of persona, right? It is blending in the sense single person is able to come and wear multiple hats. I know you're wearing Pi hats, but they'll be able hats and able to carry out different jobs, like doing the ETL job, SQL engineering, and then data engineering. So all of that, right? So as a next step, we're moving on to Jupyter Lab, which is a tool to process the data. And here the SAID wants to combine this data to move over to the next step, that is machine learning, right? So here you can see the Python code here. It looks complex. I mean, it's been a while since I coded, but still, right? So now we can just ask simple questions here, right? And it is integrated with Q developers across all the tools, so that you get necessary assistance wherever you go, like your sidekick.
Yeah.
Oh.
Did you see it?
Yes, I did.
All right, let's go.
I see two different questions. You want to grab the first one?
So ARRJ Berger said, is there a way to bring an existing Glue ETL flow into a SageMaker Unified Studio project?
That is coming very soon.
Okay.
Yeah.
Okay, awesome. Second question I saw, we were talking about machine learning. We're starting to blur some lines here. Does SageMaker Unified Studio work with Bedrock?
That's a great question. Yes, absolutely. I mean, one of the things here is you can build your chat applications. So Bedrock is integrated. You can see the app development here. You can come and build your chat agent, or you can build any application, Bedrock, Gen AI applications. So that is one of the things. Like I'm saying, the tools and capabilities that span across different variety of services in Amazon are all under the umbrella of Unified Studio.
Yeah. All right. Well, that is all the time that we have for this demo today. Where can people go to get started? What's next?
Yeah. So it's pretty easy to get started with Unified Studio. You all can log into AWS console, and it's very easy to create a domain with a couple of steps, and you can get started and take it for a spin. And we hope you're gonna enjoy working with Unified Studio. It's going to solve all your problems. Thank you.
Yeah, awesome. Well, this is AWS Pi Day. Stick around for more content. We have a couple of more very interesting things for you. Adrian, what are you looking forward to?
Looking forward to talking shop again. We did some time traveling here, if you remember correctly. We've got a session that we're going to bring to you while we take a short break here, but hang tight. We've got a lot more cool stuff to talk to you about. Look forward to it. Stay tuned. We'll be right back.
Hey, folks. Thank you so much for joining us on Pi Day, where I can promise you I will continue to be as irrational as possible. My name is Adrian San Miguel. I'm a principal enterprise architect here at AWS and joined by my good friend Jasmine. Say hello, Jasmine.
Hello, my name is Jasmine Kyles. I'm a manager of product management here at AWS, and I'm so pumped to be here for Pi Day. This is Pi Day from the past, so we're headed, they'll see it at Pi Day in the future, right?
Good. We got to keep up with the stream. I honestly think that if we bothered to measure the radius of time that we're going to be doing this, as we like to say, in the fullness of time, we'll eventually get there. And I really do look forward to watching this here in the future.
Yeah. In like 3.14 plus some other numbers.
Honest to goodness, nerd pride. At one point, I had like 20 digits of pi memorized, and then I realized nobody really cares about that. After we realized computers can do a lot better job remembering numbers. But yeah, just useless fun fact about myself. But I digress. I could tell you about them all day.
So what are we going to talk about today, Adrian?
Not boring factoids about my life. What we are going to talk about is how folks can start doing things like change data capture to Apache Iceberg tables in S3 using something called Data Firehose. And I think instead of hearing me talk about it, we'd like to hear from our guests. Let's go ahead and bring them on. Hey, Fanny.
Hey, Adrian. Hey, Jasmine.
Welcome to the show. So tell us who you are, what you do at AWS, and what are you going to talk to us about?
Sure. Hey, first of all, thanks for having me here. My name is Farindra Uliargoli. I'm the product manager for Amazon Data Firehose. I've been with AWS for 3 years now. I'm pretty excited to be here talking about the new feature that we recently launched that will greatly simplify customers' data pipeline, bringing their operational data into SageMaker Lakehouse.
Well, that's a lot of very big words. And like I was mentioning before, I grew up in the data center, so I have familiarity with some of them. But for some of our guests or viewers rather that are watching potentially for the first time, can you help level set and have them understand what Amazon Data Firehose is?
Absolutely. So Amazon Data Firehose at a high level is a fully managed serverless streaming service that captures real-time streaming data from various streaming sources and delivers to destinations such as data lakes, data warehouses, and analytical stores. Since Firehose is a fully managed serverless service, customers don't have to manage any of their infrastructure or manage capacity, develop a managed code. So it completely eliminates the operational burden they would otherwise have incurred. Yeah. So in short, Firehose makes it easy for customers to move their real-time streaming data into various destinations.
Cool.
Nice. And so what type of customers would benefit from this, or, any popular use cases that we could consider when we're, thinking about what this might look like?
Yeah, anybody who would like to move their data, right, their streaming data, real-time streaming data into the data lakes, warehouses, analytical data stores, right, would use Firehose. Primarily, customers use Firehose to capture the real-time streaming data such as clickstream events, IoT events, and game events, or AWS service logs such as WAF logs. They would like to move this data into Amazon S3, Amazon Redshift, OpenSearch, Splunk, and 20 plus third-party destinations that Firehose is integrated to. They would like to move this data primarily for their data analytics or to use this data to train their AI ML models or for archival reasons.
Yeah, I mean, you're speaking my language here with having to stream the things, collate the things that actually do something with the things. I remember growing up in the data center and setting up something like Elasticsearch for the first time, and we were actually able to go through and figure out what the alert correlation was and really make sense of it. But this is just that at a significantly larger and more sophisticated scale. Is that about accurate?
Yes, that's correct. Yes, we have thousands of customers using it, right, ingesting petabytes of data, right, per day. Yes.
Yeah, it sounds like that benefit right there that we're hearing part of this about is going to be that reduced complexity for, the builders here, anybody who's managing these large data sets.
That's correct. So Firehose is a no-code service, which means customers don't have to develop any code, right? Just they have to set up the stream and and that gets the data going right from the source to the target destinations.
Yeah. Could that source be like a data lake, for example?
No, it's primarily real-time streaming data sources. It could be existing AWS streaming sources, services such as Kinesis Data Streams or Amazon MSK, or they can directly ingest their data from their data producers by using some of the APIs that are available right in the AWS SDK, or they can ingest the AWS service logs, right, which Firehose is directly integrated to, right? These are the various ways by which they can ingest data into Firehose.
Wow. You got my curiosity more than piqued a little bit. I understand you may have a demo for us, Fami. I would love to jump into that if you're ready for it.
Let's do that. So let's start from my source side. On the source side, I have what I have is MySQL client running on the EC2 instance. If you see my screen here, right now I already have a database created called sensor readings, within which I have 4 IoT telemetry data. Each of these tables are storing data that are coming from a particular IoT device. So what we're going to do is we are going to create a new table here on the source side, and we expect Firehose to create such an equivalent table on the Iceberg side automatically. That's number one. Number two, I'm going to do some inserts, updates, and deletes on the source side, which is on the MySQL side here. And I would expect Firehose to replicate those changes, right, in real time into the Iceberg tables. Third, I would like to change the scheme of one of these tables, add a new column, for example, and I would expect that column to show up in Iceberg tables automatically as well. So those are some of the core capabilities I'm going to demo. That's on the source side. So let me jump to the target, which is Iceberg tables. I'm using Athena, all right, to query these Iceberg tables. As you can see here right now, sensor readings, the database is already available along with all the tables, IoT telemetry 1 to 4. Whenever we add a new table on the source side, it should automatically show up here. Once it shows up, I'm going to do a query using select star, and we should be able to see all the inserts and updates and deletes that happen on the source side. Okay. Coming to Firehose. Firehose, again, we're going to quickly show how easy it is to deliver data right from MySQL database to Iceberg tables. Just to quickly show here, first of all, there are primarily you configure 3 sections. One is you configure the source and destinations. In this case, you would like to source data from MySQL database to Apache Iceberg tables, and that's the only destination that's currently supported. Okay. And you would give a meaningful name to a Firehose string. I'm not going to configure at this point. I already have a string that is already created for the demo. I'm going to quickly show what are some of the key configurations customers would have to go through. Once the source and destination is selected, customers have to go and select their database endpoint. And since we privately connect to this database using VPC, customers have to enter the VPC endpoint service also. And customers have to select a secrets manager secret name where they store the credentials. And the most important configuration they would do is they can select their databases, tables, and columns they want Firehose to do replicate. Right, so customers don't have to do CDC on all the databases, tables, and columns. They can selectively select some of them. And once the source configuration is done on the destination side, the key things they would configure, the optional features is enabling the automatic table creation. Once checked, Firehose would automatically create tables on the Iceberg side, matching the source schema as is. The second capability is, again, this is an optional feature. Customers can enable schema evaluation. Once checked, Firehose will automatically bring in all the source schema changes into Iceberg tables. Okay. And the last one is an IAM role, which customers have to configure, which has access permissions to write into Iceberg tables. Okay. So those are the key configuration customers have to go through. And another key thing that I forgot is about the buffer hints. Buffering is one of the key concepts of Firehose, which lets customers buffer before the write into Iceberg tables. For low sensitivity use cases, customers could set a lower buffer interval. But if the customers want a larger buffer sizes, a larger files in S3, they can configure higher buffer intervals as well. Okay, so that's on the Firehose side. Now let me jump and create a new table, and then let's see if Firehose brings it into the Iceberg side. So in this case, I'm going to create IoT telemetry 5 table on the MySQL side. Okay, so I just created IoT telemetry file table, and let's do some inserts. I'm going to do 3 inserts. As you can see, there are coming from 3 device IDs. Device ID 1112333. Okay, let me add that here. Now I've added all of this. I created a table and did 3 inserts. Now Firehose is picking all these changes, right, in real time, and then pushing it into Iceberg tables. Now let's go to Athena and see if we see the new table that we just added. Okay, as you can see here, there's a 5th table already showed up in real time. Now let's go and query this 5th table and see if you have all the 3 inserts that we just did. Okay, as you can see that all the device IDs are showing up here. So all the inserts came in real time. Now let's go and do some updates and delete. So I'm going to update the device ID 111, and I'm going to change the battery level, which is at 70% to 100%. That's the update I'm going to make. And delete is going to be, I'm going to delete the row 333, column, the device ID 3333. Okay, these are the 2 changes I'm going to do right now on the MySQL side. Okay, so I just did an update and a delete. So this should again be reflected on Iceberg side. Let's go check it out.
But the important thing to remember is now that you change the battery value, somebody's actually got to go change the battery, or else you're in a situation like in my house where the fire alarm went off 2 nights ago, and I had to go up and figure that out at 2 in the morning.
Correct. So somebody just charged the particular IoT device to 100%. That's exactly why we are changing it here right now. Yes.
Awesome.
So let me go and run it. When I run, so we should expect, yeah, you see for device ID 111, the battery level got changed to 100%. And also if you see the device ID 333, the entire row is missing because we just deleted it. As you can see, the inserts or deletes that are happening on the MySQL side are automatically getting replicated in real time in new Iceberg tables. So let's do one. Go ahead.
If I can ask briefly, so I could definitely see this in use for analytics and AI type solution use cases. What are the other types of, I guess, applications that you could think of that would make this important of a feature to customers? I mean, selfishly, coming from the world of databases and infrastructure, constant replication is a very good thing, and being able to have it set automatically as a managed service is even better. But what are the other type of reasons why you could think that this might be important to customers?
So customers would like to consolidate all of their data into their Lakehouse architectures, right? And this particular feature is bringing their database data, operational database data into the Lakehouses, which means they have all of their data right now available in Lakehouse in real time, which enables a lot of use cases. For example, they have all the data, they can club them together and then make meaningful insights in real time, and then use that data to do some actions, to offer some personalized recommendations, in real time to their customers, or do some real-time analytics and observe their customer behaviors and things like that. It opens up a lot of possibilities for the customers, and they can do all of this without developing any code, and that's the beauty of it, right? Just with few configurations that you have seen on Firehose, they can set up a stream, and get the data going from their operational databases to Lakehouse.
Good deal. You mentioned Lakehouse, and I think earlier on you mentioned SageMaker Lakehouse. For those folks that may have just joined us, you mind a quick explanation of what that is?
Yeah, sure. So probably you've heard about, and reInvent AWS announced SageMaker Lakehouse, which is basically a unified Lakehouse architecture that AWS is recommending, where customers can bring in all of their data into Lakehouse in a unified way, so that all the data can be accessed using various analytical tools that are available, right? And Firehose is integrated with this Lakehouse architecture, which means Firehose can deliver data into customer managed Iceberg tables or S3 tables, right? That basically unlocks the value of data for the customers. And because Firehose is directly integrated, customers can use any of the data sources. For example, customers can ingest data using Kinesis data streams or MS and MSK, and they can easily bring the data into Lakehouse using Firehose in real time.
Wow.
That's neat.
I'm kind of speechless. Jasmine, you got anything top of mind? Because I've been doing a lot of talking. Sorry, I got excited.
Yeah, no, I think I love that. And that could become, a target destination for this real-time streaming data here. So, as we're coming, kind of close on the end of this demo here, what are some of the things that are already available for customers to go ahead and get started using this?
Yeah, this particular feature is in preview. So customers, it's a public preview. Customers can go and test it out, right, by themselves. So there's no need to, approve or anything of that sort. So some of the capabilities that I just showed, right, they should be able to configure Firehose to read from their RDS, Aurora, or self-managed MySQL Postgres databases and starts replicating the data into Lakehouses right now. And they also go do some schema evaluation, test the schema evaluation changes that are happening on the source side into Iceberg tables as well. So all these features that I just demoed are already available. And we are going to go GA pretty soon. So please stay tuned. We're going to do some announcements pretty soon about the general availability of this particular feature.
Yeah. And while this is in preview, is there anywhere else where customers could go and try this out?
Yes. So the documentation is up to date, right, on Firehose user guide. So customers could use those directions to set up their Firehose stream and get this replication going from their popular databases to Lakehouse. And it's pretty easy to set up. And once the customers configure, they will figure it out like just with few clicks. Customers should be able to get the stream going for them.
Yeah. Is there anything like a workshop or an immersion day, anything like that available?
Right now, the workshop and detailed blog on MySQL Postgres are in progress. So stay tuned, and we will make some announcements regarding their availability pretty soon. We have workshops that are available to deliver streaming data into Iceberg tables. But for this new feature where for the replication of database changes, the workshop is in progress, and we should be able to bring it out probably in a few more weeks.
Awesome. So I guess the place to go is just keep an eye on that product page. Is that about accurate?
That's correct, yes. And Amazon Data Firehose user guide is the place where customers can look out for new announcements.
Fantastic. Thank you so much for joining us today, Fanny. Any last bits of guidance you maybe want to impart to the audience before we go?
No, just give it a try, and you will figure out that it's pretty easy to use Firehose to replicate database changes into Lakehouse. And please try it out and give us a feedback, and more things to come.
Great. Awesome. Thank you so much. Thank you very much for joining us. Look forward to seeing what this looks like when it hits production, and definitely look forward to streaming my own home automation events to it to continue embracing the lazy at home, because if there's a better way to do it and I can do it in a managed service, I'm going to totally do it. Thank you for having me.
Sure. Thanks, Jasmine. Thanks, Adrian, for having me here.
Hey, everybody. I hope you are enjoying your Pi Day. I'm Am Grabilny, one of the hosts here for AWS OnAir and a dev advocate here at AWS. What an exciting day, Adrian. You are live there in the studio in the future there, right?
In the future, yes. Great things are happening in the future, and I think I'm still a part of it. Hey, everyone. My name is Adrian San Miguel. I'm Enterprise Architect here at AWS, and as Ian mentioned, one of your hosts for Pi Day.
We are going to be talking with our friend June here in just a few minutes, and we're going to be talking all about how to optimize your inference, I believe. Let's get June on screen so we can ask him.
Yeah, let's.
Hey, June, welcome.
Hello, my name is June. Thanks for having me here.
Tell us about yourself, June.
I'm a product manager in SageMaker and Bedrock hosting team. And I'm happy to have the chance to share some of our latest releases that we had at the reInvent. And we've heard a lot about our new feature from our customers, and they really resonated well. So I just wanted to use this opportunity to share with greater audience.
Very nice. Now, June, walk us through, please, if you would. When you're building an application that uses inference, right, that takes a prompt, goes out, what are the ways that you're seeing our customers out there building these types of applications?
Yeah, let me start from services that we provide at the AWS. So AWS provides flexible ways to meet different use cases of our customers, especially in Gen AI use cases. And specifically, we have Amazon Bedrock for serverless offering and Amazon AI for solarful inferencing offerings. Depending on the customer's need and total cost of ownership, they choose one or the other for their use cases. Now, one thing that really resonated well with our customers lately is one of the new features that we developed for Amazon SageMaker AI, which allows customers to host multiple variants of a same model within a single instance, which wasn't allowed before. So before, for the same use case, customers had to create like 3 or 5 instances just to do the testings, for example. But then with this feature, they can actually create one instance and be very cost effective when working with multiple variants of a same model.
Actually, I'm going to jump in. Why would a customer want to use more than one model? I mean, I know a lot of folks are fairly divided in the camp, and I kind of know the answer to this already. But for the benefit of folks that may not, why would you want to use more than a single model?
Yeah, there are many different reasons, but let me talk about 3 different use cases that I've seen from our customers. So one is customers may be operating in different regions where there are different languages and there are different terminologies. However, most of the models are trained on more generic terminologies and English-based languages and whatnot. So a lot of customers fine-tune the very strong base model, such as Llama or Qwen, and fine-tune it with different languages so that the model starts to understand the nuance and the specific languages of different locations. That's one use case. The other one is customers might be operating in different business units. So there are specific finance terms that the finance team uses. There might be different terms that sales team is using for sales purposes. But at the same time, the company might not want to expose the terminologies from one team to the other, the information from one to the other. So they want some type of a segregation or isolations across different business units. In those cases, they would fine-tune a base model with different terminologies from different business units and create a 2 separate model. The last use case is when customers are trying with multiple data sets to find which is the best data set that they should be fine-tuning the model with. They may actually create 5 and even tens of variations using different data sets that they have that are tailored in different manner to see which one actually wins in their evaluation score. So those are kind of 3 reasons why they might actually fine-tune a single model, create a different variants of a different model. Now, as you can see, there are a lot of businesses and different languages, so that can lead to a lot of instances that they need to create to do these type of testings.
You got me intrigued now, June. I want to see how you do this. Can we pull up your screen? You told us you have a demo. You're going to show us how to actually use this feature, right?
Yeah.
Okay, let's take a look. I see some terms here that maybe I'm not familiar with. So I see Lora right up front. Can you tell us a little bit about what that means? What is Lora? I feel like that's key to what we're about to learn.
Yeah, so Lora and also PEFT is another terminology that is used with the Lora. Is actually a fine-tuning technique that allows customers to freeze a large portion of the model and then only fine-tune subset of the parameters so that the base core performance of the model stays while the some nuances and specific portion of the models are tweaked with the additional data sets. So this is a very good way to use for different use cases that we just talked about. And one benefit of this is not only it can freeze the core part of the model, but also the fine-tuning speed is much faster than fine-tuning from scratch. So this is a very much widely used technique amongst the customers who have the use cases that we talked about.
Very nice. All right, let's jump in. Let's see how to deploy to this one instance. I assume it's just going to share that base model then instead of having to redeploy it every single time for every variant. Is that what's going to happen?
Yeah, so I have a little picture that talks about the demo scenario that I came up with. So let's say there's a customer who has 3 different variants of a same model. and let's say Quinn model, because that's the model that we're going to use for this demo. Previously, customers needed to deploy each of the model variant into 3 separate instances, and which then costed them 3 instances of worth of cost. With the patented Lora support feature that we released on the SageMaker AI, customers can now actually put the same models all in a single instance. Exactly how that works is that the base model is loaded onto the GPU with 1 Lora adapter, and then the other 2 are loaded onto the CPU and disk. And when the inferencing happens for a specific variant model, the system automatically switches what's loaded to the GPU from the location that the appropriate Lora adapter is stored within CPU and disk. So there's going to be a bit of a delay in at the time of inferencing because of the hot swap, but we can talk about that a little bit later. But we'll talk about the actual way of how to set this up first.
Yeah, it's interesting you mentioned that, because many of the customers and partners I'm talking to, when they're trying to run their own inferencing jobs, they have to reconcile, what version do I want? Should I even go in for conversion? And then how do I go get capacity to go do this? It seems like this is really going to help them solve that in a pretty intuitive way.
Exactly. GPU capacity is very much of a scarcity resource across the globe, and this will really help them run efficiently when they have multiple models.
Cool.
All right. So I'm going to talk through how they can actually set up first the base model in an instance, and then add different Lora adapters on top of it. For any SageMaker endpoints, customers first need to create a model object, and then they need to configure an endpoint, and then eventually create the model endpoint. So let's start with the creation of the model object. The model object requires 2 information. One is the container information, especially where the container is located, and then the parameters that are going into the container to understand that what type of features are going to be used from that container. Now, in this case, because the container is something, because the feature is something that we developed, we highly encourage customers to use our LMI container, which SageMaker AI team develops and maintains. And in this website, we list different versions and the location of those containers. So customers can just copy paste that information here. Then for the environment variables, there are a couple things to note here. Normally, customers would need to define exactly what model they're going to use and batch size and whatnot. Those are all the normal operations that they need to do. On top of that, to enable the patent Lora adapter support, they need to enable it. They need to set the environment variable for Lora as true. They also need to set how many Lora adapters they want to set on the GPU as well as onto the CPU. This is a trade-off decision where customers can make between adding more adapters into GPU, which will then take out memory space for the models. And those are all the decisions that customers will make in subsequent steps. So for now, for the purpose of demo, I'm going to put 1 Lora adapter onto the GPU, and then 1 CPU, 1 adapter into the CPU. Now I said 2, but it's actually 1 because it's actually including the number that's included in the GPU as well. All right, I'm going to register this environment, and then now I'm going to actually create the model object. I defined the model name to be Quinn OnAir for this demo, specified that the image location of this particular model object is located in the URL that we designated above, and then the environment variable that we just set above as well. So if I run this, it takes about a second to create the model object. And if I go to SageMaker Studio, or customer can also visit the Unified Studio as well, and go to Models and Deployable Models, here now we have something called Quinn OnAir Model Object. Now, this actually then stores all the environment variables, the model information that we're going to use. so that next time if we want to come back to this, there's always a record of what was created before.
On behalf of the AWS OnAir team, we are honored that you named your model for us, Jim. Thank you very much.
All right. Then we'll go on to the create an endpoint configuration. This is basically a configuration for the endpoint itself, and the only thing that is usually different from one another is the instance type. In this case, we're going to use G6 16 large, which has one GPU in it. But in case customer has a larger model, they might need something larger than 16x large. Endpoint configuration is pretty straightforward. There are default values that we recommend. And then we will go ahead and actually create the endpoint name now. So we'll give it an endpoint name of live demo. And then we will kick off the endpoint creation using the configuration that we configured just above.
Okay.
This is going to take some time, so I'm not going to actually run it, but I did want to show that once we kick it off, then it actually shows up on the endpoint list as a live demo. But in the notebook, I'm going to cancel this, but this will still run at the background for the future purpose.
June, just for anybody who's new to all this, SageMaker endpoint, this is what I use to send prompts for inference, yes, to my model?
That is correct.
Okay.
Now, I do have an empty endpoint to share. So once the endpoint is created, note that it has the URL attached to it as well as the ARN. This is the resource and URL that will be used by customers to actually communicate with everything that's behind the endpoint. All right. Now, at this point, what we have is an empty endpoint with one instance up and running. And that instance is the G6 16x large that we set up. Now, what we're going to do is deploy the model object that we defined above into the instance by creating something called inference component. Inference component is a feature within SageMaker AI that allows the containers to understand how many GPUs and memories this specific model can consume from the instance. So in this case, we will define for the base model the number of GPU that the model will use as 1, and then the initial copy of the model as 1 as well. So if we have a large instance where there are multiple GPUs, if we put initial copy count as 2, what this will do is it will create 2 copies of the same model, 1 on each GPU. So this is how customers can control how many memory can be allocated to a certain model, or how many GPUs can be allocated to certain models. Now, if I run this, this will take some time as well. But notice on the on here that the live demo endpoint that we created above now actually has the base model creation in progress. So this will take about 5 minutes, so I wouldn't actually wait for it, but still this shows how customers can actually validate when things are happening, and customer can actually go and look at the logs as well. Now, once this is done, you are actually running one base model on a instance where you can start to actually run the invocation. So for now,
no variants yet, but maybe we should jump to deploying that variance, because I know we are running short of time here. So I want to make sure we get to getting to those adapters and seeing how the variants get deployed.
Okay, cool. Then let me. Oops, let me actually switch my endpoint to the a demo endpoint that I already created, just so that we can speed up things. Give me 1 second.
Sure, no worries. We do appreciate the live demo. I think everybody does. It adds a bit of credibility to it. It's really easy to have it recorded and scripted and go over and over until it's absolutely perfect. But honestly, this is what people want to see.
Yeah, thank you. All right, so let's move on to the installation of the Lora adapter. Now, one prerequisite here is that the Lora adapter needs to be already stored in S3. That's usually the most case after fine-tuning is completed, so a lot of customers would have those stored on the S3. One thing you have to do, though, is specify the location of that S3 as one of the variables so that we can use later. Here, what we're going to do is create a same inference component, but this time we're going to add something called specification that says base inference component name, and add the base component name that we created above. What this means is that here is an inference component, and this is actually associated with a base inference component. As soon as we define this way, the container understands that this inference component is meant for the Lora adapter. And let me also put the endpoint names that we created above. And we also need to specify the artifact location of that inference component, which we already stored in the S3. And if we run this, it will go through the same process of creating the inference component and storing it into the instance that base model was already deployed to. Now, I already have this installed. So what customers will see after that is base model and adapter both installed into the instance. Now what we'll do is we'll start invoking on to the endpoint and see how the responses are different.
Yeah, it'd be great to see.
So here I'm just downloading a test data set from one of the open source data sets, and we're defining a prompt. What this does is the data set includes some of the financial reportings from different companies, and it's asking the models to summarize the financial reporting from that company. We also need to add the base component name here. At the endpoint. So at the time of inferencing, customers need to specify which inference component they want to inference to. So in this case, because we are inferencing to the base model, I add inference component name as a name.
Okay.
And then in the second case, I'm going to add the adapter name as the name of it, name of the inference component.
Okay, there we go.
All right, so both inferencing has been done, one on the base and then the other on the adapter. Now let's actually see how they are different.
Perfect. So, we're right about at time, so this would be perfect to show those results.
Yep. So ground truth is the input data that went into the prompt, and then see that the first base model is responding with one type of narrative with a bit of a bullet point metrics, whereas the adapter version is a full narrative version of the summary of the financial reporting. So this is how customers can actually compare and contrast between two different behaviors of a same model that were trained on different data sets.
Love it, June. Unfortunately, we do have to run. I know there's always more to see, but we're going to leave that to you, the audience, to go out and try. We got some links, I'm sure, that we're going to be dropping in chat now for you to get just going right now with this feature. So, June, thank you so much for joining us. We really appreciate you taking us through all this, but we got to go. We'll see you soon.
Thanks for having me here.
Hello and welcome back to AWS Pi Day. I'm Jasmine Kyles, a manager of product management here at AWS, and I'm joined here with my co-host, Adrian. Adrian, who are you?
Hi. I don't know who I am today, but I think the lower third says I am a principal partner enterprise architect here.
It actually doesn't. It says AWS OnAir.
Well, it should say something else, but we'll go with that. I'm an enterprise architect here at AWS. I've been here for a little under 9 years at this point, but we have somebody that's our guest that's been here a lot longer than I have. So, John, would you mind saying who you are, what you work on, and your favorite type of pie?
My favorite type of pie, huh? So I am John Handler. I'm a senior principal solutions architect.
I have been with AWS for 15 years. I've focused on all of our search technologies throughout that whole time. I think my favorite type of pie, I'd go pecan. I kind of like a pecan pie.
A question, do you want the pecans smoked, or do you just want them like a little crispy, or do you want them natural?
Yeah, I love a little smoky flavor in the pecan that balances the sweet from all that goop.
Yeah.
So.
Do you like it when your pecan pie is like runny, or you want it to be like super firm?
No, firm.
Okay.
Definitely firm.
All right. We can debate about that.
All right.
There's no debate.
But we're not going to do that today. So what are we going to talk about today, John?
Yeah, today we're going to talk about search. And I'm curious, when's the last time anybody used a search engine? Jasmine, Adrian?
Like in the last 30 seconds.
Like in the last 30 seconds.
I was searching Pi Day traditions when I asked the chat. So chat, we're still here with you. I want to know your favorite Pi Day traditions, but I asked the search engine to tell me about Pi Day traditions.
There you go. And, I have a graphic that I'd love to show that hopefully captures kind of some of the normal way that we engaged with search until just very recently. So you come with some kind of query, you have some information need, there's something that you want to find. You have a few words, you have a text box, you can enter some text. You hit enter, hopefully the search engine comes back with the results that you're looking for. Quite often it doesn't. And if you don't like the results, what you have to do is then try some different words, right? And maybe you get frustrated, and maybe you give up, and maybe you say, I hate search technology. Well, hopefully not, but this is the usual way that we do search, and it's really based on the search engine matching the words that you type, and sometimes we have left navigation where you can click into filters and do things like that, but matching that information against the words that are in the product descriptions, the product titles, if you're on an e-commerce kind of website, and for other kinds of searches, matches those kinds of things.
Okay.
So let's talk a little bit about OpenSearch, and let's talk a little bit about search engines.
Okay.
So OpenSearch is a fully open source Apache v2 licensed search engine, log analytics and observability suite, and a vector database.
Okay.
Fundamentally, what is a search engine? A search engine, I take my products, I take my catalog of items that I want to be retrievable, I format them as JSON, I use the REST API to send them to OpenSearch, and OpenSearch then indexes all of the text, all of the parts of that data, so that then I can run a query to go retrieve that data. It's very much like a database solution. In fact, a search engine sits in the databases world.
Okay, makes sense.
So now with our advanced foundation models, our large language models, we're able to take that text and expand those terms to capture the context, the word context around them, and create these large dimensional vectors that place all of that data into a space where things that are like one another are near one another. So once I have my data coded as vectors, I can take a query and code it as a vector and match within that space to bring back similar or related items. And really that's the core of semantic search. That's the advancement that search engines have seen in the last few years. So when I use OpenSearch, it's more that I have my information goal, I maybe specify it with some words, and then I send that to my vector, my large language model to code it. I do the matching that way and retrieve. And in that way, a query like shoes for the beach, where I might match shoes, but I probably wouldn't match beach, that context of beach comes in, and beach shoes then become higher ranked in the results, and I'm able to match them better. So that's the first kind of shift that we've seen. The second is that often you don't want to just type words. You really want to be able to have a conversation. It's almost like you want to go to the store and you want to talk to a representative there and say, I'm going to the beach. It's going to be 150 degrees. I need some really nice soft shoes that I can go and play on the beach, and then engage in a dialogue. Large language models, foundation models, and AI agents are providing the capabilities for us to be able to have those conversations. Fundamentally, what we do is you take all of your data, you encode it as vectors, you bring it to OpenSearch service. You write a chat application or an AI agent-driven application that takes a user question, goes and retrieves relevant items from the catalog of items, and then uses those as part of the prompt for the foundation model, so the foundation model can generate more accurate and relevant responses to the user's question, right?
Okay.
So this is the second kind of shift that we're seeing in search and how people search. So we have a demo that we can get to just to kind of see it in action.
Yeah, I've got to say, John, that's got to be one of the better, like, contextual and all-up explanations of how search works that I've ever heard.
Well, thank you for that. If you are interested, we're going to drop a couple of links. One of those is, I did write this out in some longer format, so if folks are interested, you can go to the O'Reilly Learning platform and you can go download the report there. Also, everything I'm going to demo is available as a hands-on lab. And we'll drop the link for that. It's self-guided, should cost just a few dollars. You'll be able to build exactly what I'm demoing here today.
All right, cool. Let's jump into it.
Let's jump into it. All right, so I have what is probably very recognizable as a search interface. I have my search box. This is a set of product data that is shoes and apparel primarily. So we're going to search for shoes for the beach. And we're going to use the old style search here.
Okay.
We're just going to match words, right? So if I go and search for shoes for the beach, you can see...
I'm not wearing these to the beach.
No, those don't seem like particularly appropriate shoes to put on if you're going to the beach.
Not even for a wedding.
Yep. No. You can see we've highlighted here the matches, the word matches. Primarily, this first result we're seeing is a lot of matches to shoes. But again, beach, the context, the reason that I'm searching is not in the words there. We can look at some other ones. Again, these are shoes. They're not particularly suited for walking around on the beach.
Okay.
These are definitely not suited for walking around on the beach.
I mean, you can do it, but it's not going to be well. I mean,
maybe if you were going to a beach wedding, you might want to wear those, but...
AM in the chat said maybe to Galveston. You need to wear some of those other shoes.
Yeah, maybe. Absolutely. So this is, again, the keyword-based word-to-word matching that most search engines do and have done for many, many years. Now I'm going to switch over, and I'm going to run this as a vector query. So again, we've encoded the titles and descriptions of all of the products in the catalog as vectors.
Okay.
And they are in a large multi-dimensional vector space. I'm then, the application is then going to code my query, shoes for the beach, into that same vector space and provide retrieval based on that. And what we'll see is that, again, that beach context comes in because of the correlation of shoes and beach in a lot of the products that are going to come out. So let's go ahead and run that one.
John, while this is running, like, I'm curious to know, like, what strategies would enable the efficient scaling of vector operations?
Yeah, so there are a lot of parameters and hyperparameters that you can use in creating the vectors, and a lot of parameters and hyperparameters that you can use in storing and retrieving the vectors.
Okay.
And generally speaking, you can trade off the cost of the solution, the accuracy of the retrieval, and the latency of the retrieval.
Okay.
So as you tweak and tune those hyperparameters, things like how many dimensions is your model producing? The higher the dimensionality, the more cost that you'll drive ultimately to store and retrieve those vectors.
It's like the old analogy of choose three. You know, you have three options: fast, cheap, and good. And you get to pick two, and you make your trade-offs.
It's exactly that. It's exactly that. And with OpenSearch service, we do provide a lot of means for number one, connecting to external models, things like Amazon Bedrock, Amazon SageMaker, to do that vector coding portion of the work.
Yeah.
And we also provide a lot of levers and ways of scaling within OpenSearch service. OpenSearch service has a managed clusters deployment
where you select hardware and we go deploy and run that hardware for you.
Okay.
And it has a serverless option that provides a vector database as well, where we do the scaling. You just send us those vectors.
Okay.
Right?
That's very interesting. We're going back to the traditional search. Someone in the chat said, would specifying beach earlier than shoes have the beach being the primary focus, so to speak?
So excellent question. Generally, search engines work as bag of words matching. So generally speaking, order is not important. Now, search engines do store things like positional information of terms so that you can type something like a double quoted phrase and get a result that keeps the words together as a phrase. So I wonder if here I'm going to go off script here, gang. Let's go ahead and try.
We'll do it live.
Let's go and see how good or bad this is. Let's try beach shoes.
You know, you mentioned something in there about bag of words. I too can be described as a bag of words if you ask AM.
Yeah, beach shoes is not actually doing much better. It does shift these shoes, the formal shoes, up higher. Okay. So again, it's really more about, is the term beach included on that item? So let's go ahead and run our vector search here, and let's put it back to shoes for the beach. All right, and what we'll see is, first result, groovy sandals.
Mm-hmm.
Sandals, good match for shoes for the beach.
Mm-hmm.
More sandals, bold fashion statement with these edgy sandals.
Much like numbers in the old world, those are definitely Roman in nature.
Yeah, these are a little bit Roman, absolutely.
A little bit.
So again, sort of to wrap up the interactive search part, or this strictly hit the search engine first workload, semantic search we call, we're able to bring in the context of beach and shoes to be able to retrieve results that arguably I would wear to the beach.
Yeah.
Yeah, I don't know about wearing those Roman-style sandals to the beach, but
it could minimize the amount of sand,
Yeah, I could, but as far as fashion goes, it's all Greek to me anyway. But I digress. John, this is pretty helpful to help folks in chat as well as anybody following along at home in being able to contextualize what is going on in the background when they go and interact with the search engine. So it looks like you're clacking something out, and we're going to continue on with the demo. So curious on where we're going now.
Yeah. So number one, yes, this is absolutely something that you can use for your data. OpenSearch, Amazon OpenSearch service provides you the capability to format any data that you like, whether it's your enterprise data repository, whether it's CRM kind of data, whether it is call center data. All of those things you can format and send to OpenSearch, and OpenSearch provides that core search experience on top of those. So we're going to shift now, and again, as I said in the beginning, we have two fundamental areas where we're seeing changes in how people interact with technology. And the second one is an expectation of, or a desire for having a conversation about the thing that you're looking for. So in this example code, we have a AI agent-driven shopping assistant.
Okay.
And AI agents are, again, a new kind of technology. This one is powered by Claude Sonnet version 3 that performs reasoning on the behalf of, from the prompt to come to a good answer.
Okay.
Right? So there's an AI agent in the back end here. We're going to ask it a question, show me shoes for the beach. The agent is now doing all kinds of thinking. It has 7 or so actions that it can perform, including going and retrieving items from the product catalog.
Okay.
So it can generate an image if it doesn't find anything in the product catalog. I think that's happening now because that takes a little bit longer. And then use that image as part of a multimodal search where it's able to search both things.
Okay.
So yes, in this case, it says the image generated looks like a good representation. So it couldn't find anything for my query. But what it did was it generated an image, and then it used that image, or it's suggesting that image as something that it can use to search the catalog.
Okay.
And we have to think about the usual interaction. You go into a store, you say, well, I'm looking for shoes for the beach, and they bring out a pair of shoes and they show it to you, and they say, like, what about these? Right?
Yeah, you go through the hemming and hawing, like, yeah, those are nice, but the holes are a little too big, and they're not going to let the water through. And
Right? So in this case, these are perhaps, so it's offering then to go search the catalog based on this. But I'm going to say, no, I want something that, I want some sandals. How about?
Okay, yeah, that sounds pretty good. Chat, what do you think we should throw out there? What sort of curveball should we throw, John? we gotta make it good.
I quite like the ones that it generated. Those might be good somewhere where it's, rocky, it's not quite sandy. I can protect my feet.
Those would be good for tubing back
a good
home,
river
Jasmine.
float,
Yeah, so those are more of a water shoe
Yeah.
kind of experience where maybe I'm looking for sandals because I just want to go for a walk on the beach.
Right.
There you go.
So these are some images of sandals, right? So
Okay.
based on the image it generated of slip-on sandals with straps and soles, it's recommending me Birkenstocks and Skechers. Well, maybe those to me, I don't like Birkenstocks. I don't like Skechers. Maybe I want something, say, well, how about I don't like Skechers? Again, this is the kind of interaction that you would have in a store with an actual agent. Let me click go. All right. And while we do that, I'm just going to quick pop up. Well, it's a little bit dim, but we can see in the background the agent's reasoning here. User wants sandals specifically for the beach. I'm not sure whether it's too dim, but it can then make a function call, get relevant items for text. So then it is calling the search engine, trying to retrieve those items. It gets an output that includes a hat, which is wrong, right? And so it thinks, okay, it's not very relevant, showing hats instead of sandals.
Yeah.
Let's try a different approach to find a good. So then it's going to generate an image, right? It generates the image and comfortable slip-on sandals with straps and a rubber sole. Here's the generated image. It sends that off, and it gets relevant items for the image from the catalog. It then summarizes everything, runs a Lambda function in the background to summarize and provide me with the response.
Yeah.
Right. So again, this is all driven by the agent. It is employing OpenSearch service as a search engine to pull results, but it's actually Sonnet is generating the kind of reasoning and the way that it goes about doing this kind of searching.
This is really interesting, and I think you bought these concepts and made them very, simple. Like, we've started to hear these terms, and for people who are newer to this, like, you're like, I'm hearing RAG, and I'm hearing multimodal, and all of these things, and so to bring it here. So if someone's net new to this, or they've kind of started to dabble into it, how can they go and learn more?
Sure. Well, first thing, I absolutely recommend running our lab. Again, you'll get exactly this. I deployed this lab for this demo. Right, so this is exactly what you'll get. You'll get a lot of background and good information about what it's doing and how it's doing it. Again, I'd point at the content, the link that we sent, the doc that I wrote, should be a good place to start too.
Awesome.
Great. John, always a pleasure to talk shop with you. Thank you so much for helping make this a little more easy to access, really easy to contextualize and see how the sausage is made, so to speak.
Yeah.
Folks, hang tight with us. We've got another session coming up right
Adrian,
next.
we don't just have another session.
I was going to say, but please do it.
Hey, if you are watching this, you need to go share it with someone right now. You need to like it, thumbs up it, make sure everybody sees it, because you don't want to miss what we have coming up next. We've got Jeff Barr and some special surprises for you right after this break, so stay tuned.
FSx is Asia's leading e-commerce segment for baby and kids. For us, data accuracy and quality of data is very much important. When we are transferring a large amount of data from source to target, we are finding the data missing, data corruption. When we started Zero ETL, we found that background, it's running to move data from Zero ETL to Amazon Redshift. It's very seamless. First thing, there is only a single manpower needed for this pipeline. Earlier, when we are using open source, there is a 10 to 12 people required to manage that pipeline. Now, after using zero ETL, we need a single person, because practically there is no kind of a pipeline. Ideally, what's happening in the background, it's a magic for us, because data movement is like very fast, very quick. 5, 6, 7 terabyte of a data, we are moving in 20 minutes. It's not only increase the productivity, it's also increase user satisfaction as well, because now we are able to deliver user what user wanted. Now, with the help of AWS, we are able to manage such things.
Hey, and welcome back to AWS Pi Day. I'm Jasmine Kiles, and I'm joined here with a special guest along with my co-host.
Hi, I'm co-host. My name is Adrian Sabigail. I'm a partner architect here at AWS. But nobody's here to see me. Everybody's here to see Mr. Jeff Barr. Jeff, how are you doing, sir?
Hi there. I'm special guest. I'm Jeff Barr, and I was having a great time watching Pi Day today. Listened, took a lot of notes, and actually learned a lot.
Yeah. Jeff, I bet it's probably hard to say this was my favorite part of Pi Day, but what do you think? What stood out to you?
We talked about a lot of interesting features, and something I loved is that Andy talked about the fact that we've done 98 data and analytics launches since reInvent 24, which, when I kind of think back, that just seems like reInvent 24 was not that long ago, but close to 100 is pretty amazing. That the pace of innovation just never stops.
Yeah.
Yeah, I mean, I blinked and reInvent was just right around the corner. I remember, taking the badge off, walking out, and thinking, "Oh man, get to slow down a little bit." Incorrect. If anything, the rate of launches, the iteration, it just speeds up more and more throughout the year.
It never ever seems to slow down. And something that kind of blows my mind is the fact that S3 is kind of old, right? S3 is 19 years old at this point, and at this point, most software systems that are reaching 2 decades, they're somewhat steady state. Maybe they're bug fixing, maybe they're doing a little bit of fine tuning, but with S3, we're still finding fundamental ways to make it better and better and broadening the surface area for our customers, which I think that's pretty amazing.
Yeah. And I would say we do that by listening to our customers. We get that customer feedback and say, what are the places that you're having challenges? And we got to hear about some of those challenges and like some of those features that we're building. And so we started the day with like S3 metadata. And then we kind of continued on. What else had stood out to you, Adrian?
Really, S3 tables is kind of interesting, and being able to, obviously reduce the price of tags for customers by 35%. That's a pretty big deal. But also empowering customers by being able to meet them wherever they are, whatever their tag strategy is, whatever their data retention and storage policy is. We're making it a lot easier and far more intuitive for customers to help get the things that they need to get done in an expedient manner and as cost effective as possible.
Yeah. I also love the collaboration that we saw, making it easier for folks to collaborate across teams and across roles and giving them the governance and the permissions that they need to really succeed, and help them figure out, how do we solve these challenges together or build a project on the same way. And so we saw that in the Unified Studio.
Yeah, not having to move the mounds of data, the data lakes, the oceans at this point in some instances, it's big. You cannot be underappreciative of the level of effort that it requires to move data in a safe and cohesive way. Being able to analyze it where it is by just letting the right person in with the right amount of permissions is huge.
Yeah, and the collaboration isn't just about between people. I think what I really saw today was the services themselves are actually collaborating a lot more. And like you've got your tables in S3 tables, and you can use all different services, Athena and the Lakehouse and all the other services to get to that data really easily. And I think that's something maybe we're doing that better now than we have in years past, where I think we were awesome at making these individual services, but making sure that they smoothly connected to each other and data flowed back and forth, and that you didn't have to spend a lot of time setting up roles and permissions and so forth. I think we're maturing a bit and getting better at that.
Yeah. AM in the chat asked, did anyone figure out that the key to Pi is Lime yet?
The keys to Pi is what?
Lime.
Oh, definitely key lime is a good pie. Although I actually like lemon meringue. You need that meringue with that nice kind of frothy foam to balance out the sharpness of the lemon.
That's the first time that we've heard like a tangy pie or like the meringue today. We had a lot of folks into apple pie. We got some pecan pies.
We did.
Yeah.
We did hear a lot of pizza pie as well as pineapple.
I love pizza more than most folks, and we actually have a pizza oven in our house. So I don't think pizza is a pie. I mean, you can stretch the definition a bit, but if you put dough on top of it, maybe that's not even a deep dish. That's just this weird variant just to suit the definition. So I'm not sold.
I'm gonna say it sounds definitely more like a casserole at that point.
Oh,
it does. Gosh. Yeah.
I could see this being a challenge for vector search to help us answer that we just saw from John. Traditionally someone might say pizza is a pie, but how could we dig a little bit deeper in there? Jeff is saying no.
Just because it's shaped like a pie doesn't make it a pie. So I've got a really important question though for the two of you. I love puns, and I love to actually kind of twist my brain in weird ways. But okay. Let's see. So we talked about some cool features today. One of the most important ones we talked about. Okay, that feature intersects with a boat and it sinks. What is the only logical name for that boat today?
Well, Titanic hitting the iceberg. I don't know. You got me.
Keep on thinking. It'll come to you.
Pie.
You're so close. You got it. Yes, the Titanic.
Titanic.
Oh, Jeff.
I actually tried really hard to get an AI to come up with that pun, and it would not come up with it. And I finally gave it the answer, and it kind of reversed and complimented me that it was a good pun. So.
Oh.
Yeah, so I won't be replaced with AI anytime soon in my puns.
It's funny you mentioned AI and replacement. There has been an ongoing effort for going on 8 of my 9 years at AWS where folks have been trying valiantly to build a bot called Yo Adrian to kind of get me to scale out and be a better source of truth that is far less grumpy and more personable by dumping everything in my brain into it. And it's been a pretty cool thing to be a part of. And hopefully at some point I can augment myself a little bit or augment capabilities of others and get them to learn cool things that I might know. The useless movie trivia and pop culture references, I don't think I'm going to dump those in because ultimately at the end of the day, they only benefit me.
But those would actually be the easiest to automate, right? Because all that data is there. So making a bot that actually asks you a quick question to make sure you're human from trivia might be kind of a cool thing to do.
So kind of flipping the script a little bit. Instead of the captcha saying verify you're human, we're going to verify that you're a bot.
Exactly.
Interesting.
Right.
Interesting.
And then do either allow or disallow that based on your preference.
I like it. I dig it. You're dropping some knowledge bombs.
I like that idea. I want one that just when someone just messages me, hi, ... it just blocks them forever.
Auto block null route forever.
Yes.
Someone in the chat says, I need a punny bot. I could do that.
Yeah, sure.
AM might be my very own punny bot because he asked, what about a pirate ship?
But I don't think he realizes that 3.14% of all sailors are pirates.
Yes, approximately.
Well, that is incredible.
You know, Jasmine, you did mention chicken pot pie, which I do think was kind of definitely a good variation on the pie concept. But that definitely is a
You consider that one a pie? Okay,
that's
definitely,
a pie, right?
most definitely pie. Okay,
But
I like it.
I'm not sure what the pot part of it is. With the chicken and the pie, I'm not quite sure what.
I'm not either. I don't know where that came from because it's more of a dish that it's in, but you know.
Should just be chicken pie.
It's I don't know about that.
Exactly.
That feels odd.
You know what is not odd? We've been talking a lot about shop. We had great interactions with chat. Thank you so much for hanging out with us all day. You know, certainly our cups feel like they runneth over, but we would be incomplete without talking about our favorite mascot of all time.
Our favorite mascot of all time. Who could it be?
Who could it be?
Who could it be?
It is Buckets.
It's
Buckets.
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 Hello, Buckets. Happy birthday, Buckets.
Happy birthday, Buckets.
We're so excited to have you. It is always a hit and wonderful to have you. We don't know what we would do without you.
We would not.
All this pie is for you, Buckets. Yes, for you, for your birthday, the celebration of Amazon S3. But it's really all about you, the viewers, in addition to Buckets. So we want to thank you for being here with us, coming with us on this live stream journey. We've been here for quite a few hours. We thank you for watching us. Take the time to like, comment, subscribe. We appreciate our entire crew, our product management team here, all of our product marketers, and of course our ASL interpreters, cast and crew that make this all possible.